The Chernobyl accident back in 1986 has triggered a lot of scientific activities around dispersion modeling. In a sense, unfortunately, it's been the first large-scale data set that we could actually use to do model validation. When I started in this file, a numerical weather prediction could resolve scale around 200 to 300 kilometers in horizontal, could resolve a time scale of the order of a few hours. Today, we're talking about 3 kilometers or less in terms of horizontal resolution and time scale ranging from a few seconds to a few tenths of a second. And we'll get to that in a moment. Clearly, dispersion modeling improvement is directly linked with the progress in meteorological modeling, and again, we'll get to that in a minute. Quick background, the early days, for the most part, high-performance computing had two main clients early in the 50s, so the development of nuclear weapon and numerical weather prediction. And so you see a picture of those epic era, that's the Bendix G20 in Montreal in 1963. We're way beyond that. An interesting paper, if you want to look a little bit at the history of using atmospheric-related tools to do source identification, can be found in the bulletin of the American Meteorological Society. It's a paper by Lester Makta from NOAA, and he did a bit of an overview paper on the finding of the site of the first Soviet nuclear test back in 1949. So you will see what those epic era look like. What you see there is essentially hand-drawn back trajectories using 500 millibar winds, which is roughly at 20,000 feet or 6-kilometer height. It's a little bit small, but I would like to draw your attention to the last two rows there. Second to last is the evolution of supercomputing. I mean, there's the progress in terms of the modeling of the various components of the environment is directly linked to the progress in high-performance computing technology. So on the left-hand side, the first Cray 1, which had the power of approximately 1/10 of any of your smartphone that you're carrying on your belt today. On the left-hand side, nowadays, Cray system available right now. Each unit essentially having 10 to 20,000 times the power of your mobile device. And the last one is interesting because it's a simulation of a tropical cyclone, a cyclone, on the left-hand side with a 200-kilometer resolution, and on the left-hand side with a 3-kilometer resolution that was run at Deutscher Wetterdienst just as a demonstration. So huge progress. What you see there is a bit complicated, but I'll draw your attention to two lines, the black line and the blue line. The blue line is an indication of the evolution of the forecast quality for a 5-day forecast since 1976. And the black line is the corresponding evolution of the computing power. This is a Canadian figure, but I mean, if you go in any other major center around the world, they have similar graph to show. And in a sense, over the past 5 decades, you need approximately 10 years to get a 1-day gain into predictability. So over the past 50 years or so, it translates to a 5-day increase in predictability. Where we are now, let's start with the first animation there. So what you see there is an animation of a global deterministic prediction system. What you see is the evolution of the cloud over the globe at a resolution of 25 kilometers. So that's the first basic set of tools that most major weather centers around the world have. Now we will zoom onto the regional version of that global modeling system, running over an extended North American domain at a resolution of 15 kilometers. Again, this is the same pattern. And of course, this is not enough to take into consideration higher resolution phenomena associated with topography. And there's a Canadian domain being run at a resolution of 2.5 kilometer, and that takes into consideration the interaction with land, in particular with the biomass of the land. And to really resolve complex topographical domain, then you could run those modeling system at a resolution of 1 kilometer over what you see there is the west coast of North America. And if you look carefully, you actually see the generation of mountain waves as well as the generation of low-level cloud associated with the topography. Those modeling systems right now are integrated, fully coupled atmosphere, ocean, ice modeling system. What you see there is the evolution of the temperature gradient at 40-meter depth in the ocean. So this is the west coast of North America. This is important, in particular for tracking of biomass that have a tendency to concentrate around those stronger temperature gradient. But those systems are fully coupled now. Canada, along with the European Center for Medium-Range Weather Forecasts, have been the two first centers, the first two global centers around the world to run a fully coupled atmosphere, ocean, and in the case of Canada, ice, global and regional modeling system. And speaking of ice, what you will see there is the evolution of the ice over the Canadian Arctic, running that fully coupled modeling system. And what you see there is the cracking and the generation of polynya associated with the passage of our large-scale meteorological system over the Arctic. Those systems can be run on much finer grid right now. What you will see is the buildup of the ice cover over the St. Lawrence River and the Gulf of St. Lawrence on the east coast of Canada over a full season, starting from January, and we will go all the way to March. Those systems are fully coupled, they're run in real time. This is an animation of multiple run over a 3-month period, but I mean, those systems are being run on a daily basis. I'm showing Canadian example, but there's 9 global centers around the world that are running similar capabilities. And again, if you look at the detail, and of course I will have no time to talk about the validation of those modeling systems, but again, you see the cracking of the ice associated with the passage of a synoptic scale meteorological system over the area. And this is of particular importance for, amongst other things, but for marine transportation purposes. Now, if you're able to do that, it means that you're able to simulate sea surface temperature. And we'll get to that in a second. What you will see is the animation over a long period of time of the sea surface temperature over the North Atlantic. And of course, what you will see is, I mean, the complexity of the Gulf Stream wall, and we all know the importance of that. So you go from the yellow, the warmer color, all the way to the blue, which are the colder color. And you can actually see the detail of the vortices associated with the north wall of the Gulf Stream. This is important. There's a number of military applications associated to that, but there's also civilian applications, such as the importance of those warm pools around the north side of the Gulf Stream when there are tropical cyclone moving from the Caribbean all the way up to Canada. So this is the first animation I wanted to show you. So tremendous progress over the past 2 decades. And there's a number of things that we can do with that. And we can go on the next slide and start the next animation. I presume I can do that. Yeah, if you could start the animation, please. So what you see there is related to air quality prediction system. So what you see there is an animation over a few months of PM 2.5. So particulate matter smaller than 2.5 microns. They're extremely important from an health perspective because at 2.5 micron, they can go deep into your lung and get stuck there, creating all sorts of problem eventually. Those modeling systems, those applications are run in real time again. They take into consideration tens of thousands of sources of emission. They take into consideration the chemical transformation that needs to take place in order to generate those particulate matter, along with other variables such as ozone and NOx and other species of interest for air quality prediction perspective. What you see is a forward in time animation. Those tools right now are being run in inverse mode. And they're being used to, and this is really emerging work, but they're being used to reconstruct pollutant inventories from factories, from stacks, from things like that. And I will get to the implication of that at the end of the talk. What you will see here is the forest fires in August of last year over the west coast of North America. And so what you see is really the long-range transport of smoke from those fires. When I started my career, we could barely run one forward simulation with a single source. Right now, you can essentially run these models in forward mode with as many a number of sources as you wish. It is really a factor of the computing power that is available to you. Again, validation of this work is extremely important, and again, unfortunately, there's no time to go through that. But all that to say that these modeling systems have reached, a high degree of precision, and of course, Mother Nature being chaotic and difficult to predict, there is actually a value to be extracted from this chaotic behavior, and we will get back to that in a minute. Application closer to potential application with the CTBT, so volcanic eruption. So this is the famous Icelandic volcano that I will not dare to pronounce the name, but you see an animation over a few days of the plume from that volcanic eruption, and the green lines are essentially the airline track over the North Atlantic there. We will get to some of the potential application of CTBT-related work associated with that. But a lot of transport and dispersion modeling is being used as an application of those sophisticated modeling systems. The next frontier right now is the coupling of hydrological modeling system. So this is an experimental version that we have over the Great Lake, around the Great Lake of North America. And this modeling system is essentially generalized to all of North America as we speak. And of course, you keep drilling down into higher resolution. What you see here is a 250-meter horizontal resolution and simulation over the Toronto area. You see two things there: the buildup of the heat island over the city of Toronto, as well as the convective resolving scheme that actually generate cumulus convection. Those are the white puff that you see there. And I could actually show you satellite imagery valid at the same time, and you wouldn't know how to make the difference. And of course, getting to even smaller scale, those modeling systems, what you see here is an animation of the dispersion of a dirty bomb in downtown Toronto. That's obviously never happened, but this is just to showcase at a resolution of 5 meters. Those modeling systems resolve actually the urban topography, so the shape of building with a resolution of 10 centimeters. And again, they can be run in real time should there is a need for that. I would like to point out that this is really for the animation purpose. I mean, clearly the plume is not interacting, but as part of the modeling system per se, there are interaction between the pollutants and the buildings from a dynamic perspective there. This is extremely useful and is being used actually by first responder when something happened. It could be a fire of a toxic chemicals, or it could be something more serious such as a chemical, biological, or radiological event in densely populated area. Again, fascinating progress over the past 20 years. And of course, we will stop showing off on this thing there. But I have mentioned that those systems are coupled with the ocean. So what we will see there is the release of a tracer in the port of Vancouver. So it could be oil, it could be anything. So this is a surface release, but bear with me that the ocean model is a fully three-dimensional modeling system there. And what you see there is the impact of the tidal activities on the dispersion of the oil plume should there be a release. And as well, it's probably too small for you to see, but you can actually see the bleaching of the particulate on the shore. And this is being used when there is an accident. This is being used in real time by a first responder to determine where they should actually concentrate their cleaning up activities. And I believe this will be the last animation. So tremendous progress over the past 20 years. You cannot do serious atmospheric meteorological modeling these days without complex data assimilation technology, nor can you do it without having a fully coupled ocean, and in the case of Canada, fully coupled ice. Which means that you can actually deal with forecast of weather, but as well as other environmental variable from the next few seconds all the way to the sub-seasonal to seasonal forecast. This is where the ocean is really playing a very important role. Now, I mentioned chaos. This is important. Over the past 15 years, a lot of work has been done in ensemble prediction. What you do essentially is that you do slight perturbation of the initial conditions in a certain way, and you run these models forward in time. Therefore, it allows you to, I wouldn't say it, you're taking advantage of the fact that nature is chaotic. You play with it, and you generate a set of solutions that will give you sometimes a fairly concentrated set of solutions, which means that the certainty of your forecast will likely be quite large. Or if you really end up with a really highly chaotic situation, then you know that the uncertainty will be fairly high. But there's a value of actually knowing that. I mentioned earlier that through the World Meteorological Organization, so there's a number of centers around the world that have similar capability. To name a few, Montreal being one, Montreal, Washington, UK Met Office in the UK, Météo France, Deutscher Wetterdienst, Beijing, Tokyo, Melbourne in Australia. Seoul in Korea as well. So you have a network of centers. They're not working independently. In fact, those simulations I have shown, I mean, this is the kind of information that is being shared in real time between all of those centers. Well, I don't think I need to convince you that a lot of the work around infrasound technology has benefited, and I'm a firm believer that it will strongly benefit from those development in the era of atmospheric monitoring. I will not go through the detail there, but all that to say that there was a very interesting presentation this morning coupling ground-based LiDAR, sophisticated atmospheric modeling in order to do further processing of infrasound information. I'm just about there. Relocatable numerical weather prediction modeling system could be used for real-time on-site inspection purposes. Uncertainty and transport and dispersion modeling, that's been the bread and butter of the application to the CTBT so far. Knowledge of oceanic current, we've talked about that. Source term estimation will strongly benefit, especially as you get to higher resolution. So not only in terms of the characterization of the source, but as well the geolocation of sources. We'll just skip that. So the future is now, I've been asked to talk about the future, and I'm well positioned to tell you that the forecast is it's really difficult to make predictions, especially about the future as a meteorologist. But there's an explosion of space-based Earth observation. The world community right now has a vision of observing system all the way to 2040. The reason being that the planning of the space mission is pretty much finalized all the way from now to 2040 right now. Sophisticated dissemination system are planned to 2030, and global data processing and forecasting system all the way up to 2030 right now. And this is really linked to our best forecast of supercomputing capability evolution over time. AI, we have a number of sessions. This will that will be a revolution in the combination of multiple sources of information. I'll say no more on that. And there's a fundamental changing paradigm that is taking place right now, and I'll stop with that, is that one can decide not to share certain data. But for sure, somebody else will be able to reconstruct that piece of information from sophisticated data assimilation and modeling technology and deep learning approaches. And this is true for military and civilian applications. So I'll stop there. This is really changing the game. We are reconstructing air pollution inventories from space right now. Copernicus in Europe is doing that. And what we find is that ground-based inventories of pollutant are most of the time underestimated by a factor of 2 to 10. So think about that, and I will stop there, Elizabeth.
Thank you very much. Okay, thank you. It was a very interesting presentation. Yes, a very impressive presentation with a very nice modeling. Thank you very much. We have time for a few questions. Have you a question on this presentation? Yes, one question here.
Yeah, as I have mentioned, there was no time to show that, but under the World Meteorological, well, each center is actually doing verification. In fact, verification goes all the way back to the 1950s for numerical modeling. So the short answer is yes, and there is as well under the World Meteorological Organization a globally agreed protocol for the validation of key meteorological and environmental variable as well, which are being shared openly between modeling centers. So the short answer is yes.
Have you other question? Yes.
Regarding the possibility. Okay. What are your views regarding the possibility of producing analysis of xenon? So you know that xenon background is very important for us. How possible would that be for major NWP to do that?
That's a good question. Thank you for asking. I think right now there are a few centers with a global air quality modeling capability. So there's no reason why this cannot be done for radio xenon, as long as we have a well-characterized inventory of the known sources, right? So the short answer is yes, and it would be very useful in case of an event to actually subtract, let me call that the global background, in order to really, concentrate on the signal and removing the noise. I guess the short answer is yes. In fact, it would be very interesting to undertake with those technologies.
Maybe another short question? No? How long takes the computation of the model you showed us?
Well, it really varies on the modeling system that we're talking about. Right now, a 10-day global forecast would take approximately 2 hours on a Cray XC50 supercomputing facility, such as the one we have in Montreal. But what you need to know is that this is really a set this is a production, right? This is a cycle from the global to the regional to the local to the application, which means that the supercomputing facility is being used 95% of the time, all the time.
Yeah,
because you have data assimilation. So you're assimilating anywhere between 15 to 25 million pieces of information on a daily basis. So those systems are continuously running.
Quite impressive. So we will thanks again.
Merci beaucoup. Thank you very much.
Jean. Excellente présentation, j'ai beaucoup aimé. So this is the end of the session now. Thank you very much to all of you for your attention.
I'm being anonymous. Do I have a mic? Very good. I am Tammy Taylor. I am the director of the International Data Center, and I work at the CTBTO. And it is such a pleasure to welcome you all this afternoon, it's already this afternoon, to our Scientific Applications Science of Climate Change with CTBT-related technologies. I'm going to quickly introduce the panel to you, and in the interest of time and really in an effort to get to your questions, we've agreed today to integrate a lot of the expertise, the wealth of background and experience these panelists have in the context of some of their answers to a few prepared questions that we have. So let me just quickly introduce the panel to you. To my right is Mr. Matty Goldberg. He is the Program Officer for the Adaptation Unit at the UN Climate Change Secretariat. Mr. Goldberg was part of the UN Climate Change Secretariat teams that helped governments of the world to negotiate a set of global instruments for dealing with climate change. To my left is Ms. Lucrezia Terzi. She is a research scientist with the Belgium Nuclear Research Center. Her studies include climate change patterns using beryllium-7 recorded by our radionuclide network of the CTBTO. Rebecca Manzo is the acting director of the Meteorological Services Department of Zimbabwe. Ms. Manzo coordinates the provision of meteorological service products to stakeholders in agriculture, water, energy, health, and aviation sectors, as well as also steering all the seismology efforts. Hanne Sagen is a research leader at the Nansen Environmental and Remote Sensing Center in Bergen, Norway. Her background is polar research using ocean acoustic to observe the ocean climate in the Arctic region. And finally, we have Jean Sarre. He is the director of the Energy, Environment, and Water Research Center of the Cyprus Institute. Professor Sarre's expertise covers atmospheric sciences and climate. So we're going to start with Mr. Goldberg today. And I have a couple of things for you to ponder as you introduce yourself and answer these questions. First, Mr. Goldberg, how is science integrated into the UN Climate Change Secretariat process? And then what specific entry points exist to introduce observations, data, and research into your Secretariat's processes?
Hey, good afternoon, everyone, and thank you, Tammy, for that question. To answer that, I'll give you a very short background of the Paris Agreement, the main framework that we work within, the role of science within that framework to some degree of detail, and then followed by some more potential entry points between the UN climate process and the CTBTO. On the screen here, theoretically, you might be able to see something, but looks like we have some challenge with the projector here. Pressing the right button. Okay, just one moment. Maybe just to say a brief introduction to what's coming up there. People often say, you hear that in the media and other sources, that the UN climate negotiations are going in circles forever, circles continue. So I thought interestingly, it's appropriate that the Paris Agreement actually establishes a circle to deal with the issue of climate change. And as soon as my slide is up there, I can walk you through it in some more detail. See. Okay, very good. Yeah, sorry for that delay. So the Paris Agreement is the main international treaty to deal with climate change that we have today. It has two goals, which you can see in the middle of the cycle, which are to keep global temperature increase below +2 degrees, preferably below 1.5 degrees. And another goal is to adapt accordingly. And the way this agreement basically functions, it functions through a cycle. The cycle starts on the top left through a process of national targets to be provided every 5 years, and these should be, each target should be more ambitious than the previous one. There is a comprehensive process of reporting on greenhouse gas emissions and actions, and that is done every 2 years. This is followed by a process called a global stocktake, where governments and other organizations basically consider where we are with the implementation of the agreement, and then what's our progress towards the goals of the agreement. And then from that, basically certain recommendations can be articulated, and then governments can consider those in the next round of their targets. And so the cycle goes around every 5 years, and with the intention of it resulting in an upward increasing ambition of efforts. In terms of the science, the Paris Agreement outlines a set of specific entry points, and basically I've characterized them in 3 categories. First of all, there are certain collective aspects. One is that the best available science should inform the global efforts, and it should also inform this process of stock taking that I mentioned in my previous slide. So science will tell us, give us a baseline for how far or close we are from, for example, the 2 degrees goal. Secondly, there's provisions for science feeding into individual efforts of countries, mainly to be a basis for rapid reductions in greenhouse gas emissions, and on the other hand, in adaptation actions. And then thirdly, the Paris Agreement identifies certain forms of cooperation that countries should engage in, and that includes sharing of scientific knowledge, that includes research, systematic observation, and climate services. And all this should inform decision-making. So the Paris Agreement wants to basically connect a scientific basis with decision-making on climate. So that's on a very kind of, I would say, high political / international law level. Coming to my next point, and this is a bit of a spaghetti graph, but it's just there to illustrate complexity. These are various arrangements that feed science into the UNFCCC process. And there's no one-stop shop for where science goes in to the policy process, but rather there's a cluster of networks and organizations that coordinate and provide input regularly to the political conversations. And there's basically 4 broad areas here. The first one is observations. And here, for example, the Global Climate Observation System plays a central role in terms of coordinating and linking and standardizing research. For example, by outlining a set of what's called essential climate variables that should be monitored. The second area is research, and this involves then taking the data and doing analysis, modeling, and publications. And here, for example, the World Climate Research Program plays a central role. Third is assessment, and this is the role of the IPCC, which takes the peer-reviewed science and makes basically every 7 years a large assessment report of that, plus other regular reports. And these basically interact with the UN climate policy process in 2 different ways. There's, for a lot of our operations, such as this global stocktake, there is a specific scientific input expected for that. And this applies across the board for emission reductions, for adaptation. So there's always a certain specification of what kind of scientific data would be useful. The other thing is that at the UN climate conferences, we have regular events where latest science can be introduced and where there's possibilities to get feedback from the government delegates. And there's an essential function there because the IPCC reports are made every 7 years, whereas there's a lot of science happening between those reports. And there's, of course, there would need to be a channel where that information can enter the political conversations. So on that basis, I've just, after some brainstorming at home, we've put together here a few possible entry points where the data and research that's done in the context of the CTBTO can connect with the UN climate change conversations. So the first two bullets are basically events that we as the Secretariat organize, where there are various options for presenting latest research by organizations. And in those conversations, it's a dialogue between the scientific side of things and then the government delegates who are there in the room, and they provide information on their research needs as well. My third point, IPCC is preparing its 6th assessment report and has encouraged scientists to publish papers before that so that they can be taken into account, and I've added the deadlines there. An additional option there is to register as an expert reviewer. Fifth point, the GEOSPHERE, the Global Climate Observation System, has a implementation plan, and their organizations have been invited to participate in that in terms of if they have data that relates to the essential climate variables of the GEOSPHERE, then that's one point of interaction. And then finally, and maybe very importantly, are the national centers and regional centers, because obviously that's the UN, but at the UN level, the connections are basically through these organizations. But through national and regional centers, there's I think, a wide range of specific possibilities. So that's my overview of from my perspective, and I'm happy to take any questions later. Okay. I hope I didn't take too much of your time. Thank you, Tammy. Thank you, everyone.
Thank you. Thank you. So one of the beautiful things about working with scientists and planning for a scientific panel is the discoveries that the scientists start making real time right in front of your eyes as you're planning. And this occurred between these two women as we were planning for this event. So I'm going to apply this question to both of you, and you can divide it up however you like. Beryllium research with respect to using the radionuclide of CTBTO was something that really intrigued me about the research that you're doing, Ms. Terzi. How can we apply beryllium trend observations to civil use at the national level first? And then, do these observations strengthen the position for man-made contributions to climate change at this point in your research?
Yeah, so the climate change research using beryllium, it's a fairly recent one. We're working on it since half a year about, and what we found out is we looked at the IPCC report, and we went through all the areas where we had low, that they had low confidence. Yeah, so like weakening of atmospheric circulation or poleward movement of atmospheric cell. These are all side effects of global warming. And because we knew from previous studies that it's possible to use beryllium-7 as a proxy or like as a tracer for meteorological phenomena, we just focus on those low confidence topics. And exactly in the framework of the Paris Agreement, you have the part on mitigation and adaptation. And in both, CTBT data can play indirectly a major role, because for mitigation, what we found out is that, for instance, certain countries have a trend of an extension of the summer period. Yeah? So the summer period it's enlarging over and over with time. And that the trade winds are slowing down. This is something that you can also prove with beryllium-7, that you have this static weather system. And if you assess if you can quantify the trend, then you can reassess what is your goal to slow down. How do you say? You can reassess the target, yeah, because we may going at a faster speed than we think. And in terms of adaptation, the main point is the seasonal weather prediction. So that's something that we published in February, and we realized that it's possible to be highly accurate with cosmogenic radionuclide to predict monsoons, not just in India, but anywhere where they are triggered, where the monsoons are triggered by atmospheric cells. And with an accuracy of plus minus 3 days, it can be of huge help logistically and for agricultural planning, not just in India, but anywhere in the world where this phenomena happens. And I think on this, I would like to show you a video that was done based on the paper that came out in February. Oops, if it works. Go. There should be sound with it.
This all went flawlessly yesterday during the test drive, by the way.
Monsoons impact millions of people every year. Farmers rely on rain for their harvests, and lives are threatened by flooding or landslides. And yet, it remains very hard to predict monsoons early and accurately. European researchers have now devised a way to estimate the monsoon season in India. This innovative approach uses a rare isotope, beryllium-7. The forecasts are not only more accurate than traditional methods, but also available earlier, which could give governments and residents more time to prepare. This unusual weather tracking approach works because of how air circulates on Earth. Each hemisphere features 3 large-scale patterns, or cells: the Hadley, Ferrel, and polar cells. Where 2 cells meet is a convergent zone. Monsoons, seasonal shifts in wind that trigger heavy rain, happen at the Intertropical Convergence Zone, or ITCZ. Monsoons are seasonal because the Earth's tilt affects the ITCZ's location. In the summer, sunlight is strongest and warms the air more to the north. That coincides with India's rainy season. In the winter, the ITCZ and hence monsoons move south. Beryllium-7 comes into play because it can trace what's happening in the atmospheric cells. It's created in the upper atmosphere, when cosmic rays bombard nitrogen and oxygen atoms. The isotope attaches to aerosols and is transported in atmospheric cells. Beryllium-7 can then be detected by ground monitoring stations and therefore help predict monsoons based on the movement of the zones. Beryllium concentrations are high right under the Hadley-Ferrel convergence zone, where air moves downward but low in the tropical area under the ITCZ. It turns out that when these fluctuations are plotted from stations in Russia and Australia, the beryllium-7 concentrations follow opposing trends. When the concentration at one location increases, it decreases at the other. The researchers found that they can predict the start of the monsoon more than 7 weeks in advance, with an accuracy of 3 days. That's an improvement over current methods, which predict monsoon arrivals only 2 to 3 weeks ahead, with an accuracy of plus or minus 5 days. Similarly, monsoon withdrawals become predictable with this method, about 6 weeks in advance, and accurate within plus or minus 1 week. The longer lead time could save lives and help India's economy. The researchers also hope to apply their novel technique to other monsoon regions and other seasonal weather phenomena influenced by the movement of the atmospheric cells.
Yes. So I think I hope you enjoyed the video. That was my part on the. I leave the floor to Becca.
Good morning, everyone. It is truly a privilege for me to be here. I come here as the acting director for Zimbabwe Meteorological Services. In Zimbabwe, the seismology department is under Meteorological Services. So when I became acting director, I had a headache. I'm like, how do I link these two? I needed something to link them. And as some of you may know, we ratified in early this year. So now we are a full member of the family. So when this Science and Technology 2019 came up, and the topic just hit me, that we are looking at the CTBTO technologies, considering that there's climate change that can be used for other uses. That was exciting. And the second exciting thing, when her research came through to us, she needed some data. So again, I'm like, wow, this is possible. The two departments can truly be linked. So this is my short story, and I'm truly excited that you'll find that the seismology and the MET services are under one roof. Going forward, it will make the work much easier, and I look forward to steering the ship with that in mind, because I find that as CTBTO, there's so much that you already have, that you have perfected. Like I heard the other day, the artificial intelligence, you can deal with big data, NWP, the HPCs, we are there, but we are still in our infancy. So for me, coming from the background where, as I've mentioned, it's really an exciting opportunity that there's so much that CTBT technology can be used for other than what the nuclear, stopping the war and the like. For someone in the developing world like us, we are like, those are not bread and butter issues. But when we take this, this work, the monsoon, predicting when it can come, and we are able to bring us to our situation in Zimbabwe, it will truly sell the usefulness of being a member of CTBT. Why is it that important? Zimbabwe is agricultural based, and we depend on rain-fed agriculture. So the start of season is very important, more so in these days when there's climate change. Climate change is real. As the Met Department, we can document that. It is real, and it has played havoc with our start of season. There are so many dry spells. Everything has just changed because of climate change. So the droughts, the floods, I believe we can use such technologies to help us kind of predict with more certainty, time-wise, rather than just say the rainy season is going to start from October to March. We can pinpoint that the first effective rain will fall maybe with a month's lead, a week's lead. That would really change our situation. So I'm truly excited about this because we are moving into the private-public partnerships, and we have found that those work. So that's the collaborations that we were talking about the first day. So that's me. Thank you.
Thank you very much. So from monsoons, we're going to shift over to the Arctic. And Ms. Sagan, we're hoping that you can clarify some things regarding observations and changes in the Arctic that you may have seen in your research. And then tell us a little bit about the consequences of these changes on both a regional and maybe even closer to home to you basis.
Yeah, I'll try to say something about this. I'm a scientist and I do field work almost every summer up in the Arctic, primarily to measure the changes in the ocean, both in the ice edge zone, but also under the ice deep in the Arctic. And I will try to put this into a larger setting. I'll start with the fact that you all know that this is the wrong one. Am I here? This one I know. So I start out with the fact that the temperature and the globe is getting warmer, and in particular in the Arctic. You can see here the time series of observed surface temperature since 1960 up to today. And you can see along the y-axis the latitude, and you can see that the Arctic is popping out quite red. And it means that it is the strongest warming observed on the Earth. And if you go to models, this is not unexpected. Already in the 90s, we could say that the Arctic would be go under enhanced warming and environmental change. So this plot shows also the latitude along the x-axis, and then the projected temperature change above the global average, which was measured during the 2000 to 2010. And you can see that the spread in the models are larger in the pole areas. For example, in the Antarctica, you can see that it is highly variable, but it is the large changes is in the Arctic. And the model spreads are due to that we don't know everything about the physics and how the Earth system is working. And due to this, we need observations to understand better what is going on. So the easiest thing is the satellites. I mean, you have perhaps all seen the sea ice maps from satellites, and you can calculate the sea ice extent. And this is what is done with the yellow line. It is the observations. While the CMIP-5 simulations are the gray area, and then you have the blue line, which is an average over several such simulations. And you can see that the sea ice extent is underestimated in the beginning of this period, while it is, underestimated in the first period and then overestimated in the next. And that means that the model simulations cannot take the gradient. And that means that there is something in the physics of the models that is not correct. So the Germans, they are heading out now with the Mosaic field experiment, doing a lot of measurements to understand the interaction between the ocean and the sea ice. So this is models. This is 1 kilometer models, model simulation produced by ECHO, which is a US model. And you can see that the dynamics in the ocean is quite complex. You can see here Greenland is this dark area on the left side, and the smaller dark area next to the red part is the Svalbard. I can't use my normal scientific way of pointing here, but you can see that the warm water, which is red, goes into the Arctic, and in the Arctic it cools down and it's saline, so it sinks down. So it's partly, or it is forming deep water currents with this kind of water masses. And other parts are recirculating in the Fram Strait between Greenland and Svalbard. So not all the water masses that comes in from the Atlantic Ocean goes directly into the Arctic. So what we try to do is to measure what goes in and what goes in, and then see what is left in the Arctic basin. But no, we will do direct measurements this summer to see if we can measure how much heat is stored in the Arctic basin by using acoustic thermometry. On the right-hand side, you can see the sea ice, which is breaking up. And during summertime, there is a lot of water exposed to the air, and that means that heat is transferred down into the ocean. And if this continues to be more and more the fact, then this will increase the vertical mixing, and the ice will get in contact with the warmer water, and this will accelerate the melting sea ice. Because so far, there has been a protective layer just under the ice, so that the ice has not been in contact with the warm water that is under this layer. When I say warm, it's not that warm, but you would not swim in it. But it's warmer than the surface waters. So when it comes to observations, it's not so much in the Arctic. We have drifting buoys, and we have a few moorings across the Fram Strait and north of Svalbard, but else on the European side, it's not so much data there. And as you can see, the CTBTO ocean component is not up there yet. We can use this, we would like to use this kind of system also in the Arctic to get more information. But also for the Arctic, it is important to know more about what is further south. So if CTBTO maybe in future put some pressure sensors and temperature sensors and so on these locations, it would help a lot. And by combining this with the Argo floats that is currently operating down to 2,000 meters, we would have a much better system to understand the ocean dynamics. This is what we would like to have in the Arctic, a communication cable going from north of Norway and over to Japan, equipped with scientific sensors across the whole Arctic basin, would provide us with deep water information about the ocean, but also improve perhaps what CTBTO does also to monitor earthquakes and events in the Arctic by installing accelerometers on this cable. But this is the future, and I really hope that this will come true. Then, this is Greenland. And you can see from satellite images, you can see the mass changes. The red areas are the areas with the largest ice mass losses. And this is, of course, due to the atmosphere. But this will contribute to the increase in sea level on the global scale, about 8 millimeters a year. And it will also contribute to the freshwater budget in the oceans on the global scale and local scale. And of course, and this is what you know perhaps much more about than me, it will change the landmass distribution. And this will again lead to land elevation. And this again increase the seismicity and the potential geohazards on local but also regional scales. And if you look at the map below, you can see that the CTBTO have these orange stations around. which is excellent for us in Taros. It's a huge EU project where scientists from GEOS and University of Bergen have made a catalog over events based on these CTB stations and added on the seismometers on Greenland and Svalbard. And in addition, we have put some ocean bottom seismometers to pick up the smaller events, which the land-based station not always managed to take. Then you have, as a final, the warmer air temperature will melt the permafrost, and this will impact infrastructure, the water quality for the population up there, and also the frequency of landslides. So, environmental changes in the Arctic influences the living conditions for the Arctic communities. Increased access to larger areas in the Arctic leads to a stronger pressure to exploit the resources in the Arctic, and this calls for better monitoring and projections for the region. And I hope that CTB can help us.
I hope so as well. Thank you very much. Professor Siar, what are the current climate change challenges that you're facing in the Mediterranean and the Middle East arena?
Yes, thanks for inviting me here. It's my pleasure to bring to the light this other regional hotspot. I mean, we have seen just before that the Arctic is an important regional climate change hotspot, and it's not the only one. And oops, thank you. And the Eastern Mediterranean and the Middle East is another hotspot. And if you can go to the slides that shows the region there, I will have the opportunity to show you a little bit more on that. This is the map of the Eastern Mediterranean.
He's not touching anything.
And so I've relocated in this place in Cyprus some years ago to address this challenge of this rapid climate change in the region. I hope I will have the chance to show my slides. Okay, it will be difficult to do it with my hands. So I wanted to highlight, I will start to introduce my slides like that. I will save a bit of my time and your time. The region is why we speak about the Eastern Mediterranean and the Middle East and not just the Eastern Mediterranean or just the Middle East, is because this region has very similar characteristics. And in the past 100 years, and especially in the past 20 years, it's become warmer and drier than many other places in the world. That's it. So I have focused this figure here with Cyprus that very often people don't know where is it. Very often they mix between Crete and Cyprus. Okay, thank you. And very often they are surprised to hear that where you are in Cyprus, you are at the same distance from Baghdad and from Athens. It's a European island in the Middle East. And this region hosts 400 million inhabitants with rapid population growth. It's a big challenge. Very soon it will have the population of Europe. It currently hosts 2/3 of the fossil fuel reserves in the world. But as you know, it has a strong political and socio-economic instability. Moreover, it's a strategic location at the crossroads of 3 continents, Africa, Asia, and Europe. This is a very important climate change hotspot in the world. I was mentioning it. It's becoming warmer and drier much faster than many other places in the world. And in the near future, this heat extreme could become so intense that the region, the Eastern Mediterranean and the Middle East, that the human habitability is compromised and could contribute to mass migration of people to more temperate and wealthier areas such as Europe. So it's not just a problem of the Middle East, it's a problem for everybody. And I wanted to highlight this fact and show that currently the challenge in the region is that we have very few observations to support the strong climate change. And I would like to show you here some existing networks that are running in Europe that are to monitor climate-relevant species. And this is the ICOST network. It's a European research infrastructure to monitor greenhouse gases. And it shows that in the region of the Eastern Mediterranean and the Middle East, we have no observations. If you move to other European research infrastructures, such as ACTRIS, which is aerosol, clouds, and reactive gases, again, very few information in the region. But if you go to other networks, such as NDAC, again, you are missing a big part of the picture. Or for solar radiation with the BSRN network, again, very few observations in the region. So things are currently changing. This is a good thing. And in 2019, this year, the European Commission with the government of Cyprus have joined their forces to establish a new center of excellence, MACARE, that will have the capacity to fill partially this gap of data in the region, and establishing in Cyprus a regional super site to bring all together these different networks. And I went to see the CTBTO a year ago to initiate discussions. I was not at that time interested in banning nuclear tests, but having in mind that these instruments could be used for climate change monitoring. So I'm currently in discussions with the CTBTO to install for some time some of their instruments in Cyprus, with the hope that we will establish some synergies between these different networks and the CTBTO and connect it with our activities regarding modeling that will help us to better predict the environmental state of the region and predict better in the future what will be the temperatures, relative humidity, and precipitation, all this important information that are needed for climate change adaptation.
Thank you very much. At this point in time, we want to hand it over to you. So we have about 15 minutes for questions. And if you don't feel comfortable asking the question, feel free to just load up the session in front of you and type in your question, and I can read it for you. So who has the first question in the audience? And we can't see you, so we'll need a little bit of help. There we go. First question's always the hardest. So I'll fill in the empty space. Oh, there we go. Thank you.
Hello, my name is Shireen. I'm part of the CTBTO Youth project. I have a question. The manifestations of climate change in the world, I believe they're becoming more and more obvious. But for example, in the Middle East, for instance, in Jordan last year, there was a flood, but people usually don't attribute this to climate change. I mean, we have data, just like we saw, we have evidence. Why is it still like people are not convinced that some people are not convinced that there are a real issue, like climate change is real? Thank you so much.
Maybe I can maybe partly answer these questions. Well, climate change is not just about warming, and it's not just about drying. It's also about the occurrence of extreme weather events. Flooding is one of them, and there is many flood events in the Middle East where there's a very dry area. I mean, this year was the most rainy year in Cyprus over the 100 years. For me, it's a clear sign of the strong climate change. It's also heat waves in terms of number and in terms of duration. In the region, we'll have more and more of this type of heat waves. They will last longer. And when you make this type of climate change projection, by the end of the century, there is some region in the Gulf that if you don't have air conditioning, you will not be able to live there. So The current challenge for me is today to bring more information in terms of observations to better constrain this model, because this model will be the key tools for the policymakers to implement climate change adaptation policies for the region. So,
Thank you. Yes, of course.
There's also something related to trust into new techniques. And this is something that we experience with the monsoon system, the monsoon prediction system, because meteorologists are not so used to deal with radioisotopes. We've been talking to several conferences about this technique, but it really took a very long time before it got accepted. Yeah, and one of the things we realized is that in order to becoming part of the meteorologist world, we need to integrate our system into their models. That's how we can gain their trust that this technique is really useful, because the beryllium-7 has so many applications in terms of weather prediction and in climate change, especially because what I said before, the IPCC has many areas where you cannot see easily certain phenomena, and that's exactly where these IMS data fit in, yeah, because they can provide and quantify how much it's changing, like how much the summer period is extending, and how much the circulation is slowing down. And these are parameters that are really difficult with classical tools to measure, but you need to gain the trust of the other scientific departments in order to progress.
Please.
To add on to the trust issue, for us, people would rather you start with the indigenous knowledge system. Ask them what they know about their season, what it was when they were young, what it is today. And they are definitely going to say things have changed. Because in some families, they may say, for us, we started planting on the 15th of November. So in their family, they would know that come rain, come sunshine, 15th of November, it's time to plant. But the younger generations, they are realizing that things have shifted. Maybe it's no longer November, it's now shifted to December. So once you have convinced them with what they know, it's easier to introduce the modern methods.
Thank you for that. There was a moment in our preparations where I think the beryllium research and the Arctic research were clearly linked. Mm-hmm. And I was wondering if you and Hannah could comment on that relative to the question about can beryllium-7 be used in applications in the Arctic?
Yes, so when Hannah showed her chart, I don't know if we can go back to the slide, but basically what you see is that there's a the place where you have the highest increase in temperature is the Arctic, and that is absolutely correlated with our observation, because beryllium is highly sensitive to tropopause, and the tropopause is highly sensitive to warming. So you can actually use the beryllium-7 as a proxy for global warming. And you can use it locally, so if you have a station that is close to the Arctic, you can use it to assess observation from different technologies.
Hannah, anything additional? Anything additional from your perspective on that?
I totally agree.
Okay, perfect. There was a question just a moment ago on the screen regarding how we could more effectively partner with your secretariat. Any additional thoughts based on what you've heard here today?
Yeah, thank you for that question. I think maybe one important kind of premise to mention, which I probably didn't mention in my remarks, is that the UNFCCC is not a scientific technical organization, but rather our main functions are basically maintaining the transparency and reporting arrangements on climate change, where countries report, and then secondly, to help governments conduct international negotiations around climate change. And then there's a third function, which is, I think, that's where these collaboration possibilities are more diverse. We also we organize every year 2 large climate change conferences, and these are known as the COPs. There's good COPs and there's bad COPs, and those are basically these days, they are not just a negotiating meeting, but they are a big, you could almost call it like a trade fair for climate action, where many different actors and organizations come together, and including from science. So I think that's definitely, and in the context of those conferences, there are many events related to climate science, and so that's definitely one area of collaboration. In terms of the institutional linkages, I am not quite sure about that. I would need to look a bit closely. Between international organizations, there's always certain questions about the mandates arise, so those would have to be looked at in some detail, but I think that's one of the next steps that we might be talking about after this panel. Thank you.
Thank you. So let's turn back to Dr. Siar for just 1 second. Can IMS data be used to predict heat waves as well? So India is experiencing severe heat wave, and can this be linked to climate change and dynamic shifts in the Arctic?
Well, I will be happy if I can get this question in 2 or 3 years from now, because we are discussing to get such information in Cyprus. So the objective is really for us to also to build the regional capacity and in terms of knowledge, how to exploit this type of data. I think they are extremely valuable for many predictions. I would like to be able to answer this question very soon, because it's exactly the reason why we have contacted CTBTO to develop this knowledge and to sustain it at a regional level.
Wonderful, wonderful. Hannah, you might be able to see there's a question there for you asking for a little bit more detail about the multiple purposes for the CTBTO hydroacoustic data and what it could be used for.
Yeah, I didn't touch that in my talk because I was going to address that on Thursday. But acoustics is a combined information about all the sounds that is produced in the ocean. It can be mammals, it can be fish, it can be human activities, it can be volcanoes and geohazards and so on. So it's an integrated information that you sit on, and we can use, for example, with respect to climate, use this information, for example, to monitor the migration of different species. That is one thing, and you can track them since you have the triple hydrophones. You can know the direction and see how the mammals are moving. Another approach is to use this as sensors for thermometry, that you have passive sources. You identify where the sound is coming from, and then you measure how long time it takes to the station, and then you can calculate the temperature. So that is another possibility.
Okay, great. Those are 2 good examples. And maybe just really quickly in a minute or less, Lucretia, there's a question there about your paper and how it's being received by the scientific community. Could you close for us on that note?
So I can just say that since it was published, I received a lot of positive feedback, and especially, well, we couldn't publish the data of the monsoon onset this year, but we did run the data, and we could predict with accuracy of ±3 days. So we proved the accuracy again of the method, although it was 3 weeks delay compared to last year. Which is, so of course this gave us a lot of confidence, and we are going to run it every year. And so at the moment, I think it's being digested by the scientific community.
Okay, fantastic. I'd like to thank all of the panelists and our CTBTO point of contact who organized us, Elisabetta Nava, and thank you all for participating and coming today. Thank you.
Thank you.
Thank you.
Goes front, back, you know it, right?
Yeah, front, back.
Yes.
And is there a pointer?
There is a pointer, but
okay.
it won't work for you.
Okay.
So I will try to follow your lead, and
Okay.
I'll try to follow with the mouse. Or do you want to have the mouse?
I won't use a pointer.
Okay.
I'll. Okay. Is there? Will I be able to see the screen?
Yes. It will.
Okay. Okay.
Well, then we should just, yeah, we start. Yeah, we. Should we go ahead? Good afternoon, ladies and gentlemen. If you take a seat. Just make sure everybody's seated. Good afternoon, ladies and gentlemen. My name is Nasser. I'm from Jordan, and alongside my co-moderator, Melon, from the United States, and Cormac O'Reilly from CTBTO, gives us great pleasure to welcome you in this afternoon session. It gives me great pleasure to be here at the SnT conference, and I'd like to pay special thanks to CTBTO for putting together this wonderful event, and to all the 1,700 participants for their contributions to making it a success. We have an interesting panel lined up today, mirroring really the interesting times that we come to find ourselves living in. It's been said that we are now living in a post-truth world where scientific evidence and facts no longer matter, where there's been somewhat of an emotionalization of science. And I think this poses a great risk to scientific cooperation and scientific communities like ours, and to multilateral frameworks like the CTBTO, which historically has been an excellent example of effective partnerships between scientific and policy communities. Today we have 3 panelists that are going to speak about their respective developments in arms treaties, arms control treaties, while perhaps touching on this issue of how science can inform policy. We're going to start by welcoming Jonathan Foreman from the OPCW. For the sake of time efficiency, I'll ask you to take a look at the speakers' bios in the participant book. Please go ahead, Jonathan.
Okay, thank you. So I'm going to tell you today about science advice at a multilateral treaty organization, the OPCW, which is the implementing body of the Chemical Weapons Convention. The Chemical Weapons Convention, a complete ban on chemical weapons use, stockpiling, and development, is said to be underpinned by science and technology, and you can see a very technical basis across the articles of the convention itself. If you talk about implementation of the convention, people usually focus on 4 areas: the verification of destruction of declared stockpiles, routine industry inspections, and since 2013, very many non-routine inspection missions involving allegations of noncompliance. Other aspects that are probably less known, but quite important if you think about a treaty as an international cooperation, is the provision of assistance to member states upon request, and also the obligation of member states to assist other member states who request it. And finally, science diplomacy is not actually used as a term in the convention, but there is a whole article, Article 11, on the use of the science of chemistry to build international relations and to build capacity. So it's really a treaty about science diplomacy, if you will, even though most of what we know about it has to do with weapons. The face of the people that implement the convention, if you see the hands-on work, is really the inspectors. They go out from our building and they go and they do things. But they're not the face that you normally see when you hear about the Chemical Weapons Convention. Behind the scenes, supporting those inspectors is another scientific collaboration, 26 laboratories across 19 states, and they speak to each other and they interact like scientists. They publish collaborative papers, they develop and share methods. You would think with all the science that's going on, the Conference of States Parties looks like this, but unfortunately, it looks more like this. And the people that are the face of the organization are diplomats, not scientists, and they speak in the jargon of diplomats, not the jargon of science. Interestingly enough, the Chemical Weapons Convention tells the states parties through its Article 8 that they are required, mandated, to review science and technology. That's pretty interesting. What does it look like when 193 member states of the OPCW talk about science? They come to The Hague, and your head starts spinning, trust me. So, can science actually connect to policy priorities? You can think of science as being innovation, knowledge generation, experimentation. Policy is about values and norms. How does this connect? One of the values, of course, is we want to ban chemical weapons. So the discussion, because of the diversity of views on science, often tends to the negative. There are new scientific developments. We need to do something. There are new scientific developments that challenge the way we think, so we might need to rethink how we do things. And these discussions are dominated by this idea that there's dual-use potential and uncertainty of what might happen. What does Article 8 actually say? Because it really says, review science, develop a scientific advisory board for advice, And what it doesn't say is probably more interesting. Nowhere does it say chemistry, and nowhere does it say that science is good or bad. It just says that you should review and take into account. To help us with guidance on this, we have a scientific advisory board, 25 members who can serve for up to 6 years from 25 different nations, another true scientific collaboration. Last year, they produced 5 reports. Most of them are on the website with associated documents you can download if you're interested. They run temporary working groups. We have one currently working on investigative and forensic science methods. And over the course of history of this board, there's been members from 44 different nations of the world, which is pretty amazing. So, what do they do? Well, they give advice to the review conferences, which happen every 5 years. That's a synthesis of all the work they do within the 5-year period. They publish lots of reports and guidance on what's happening in the world. The topics they cover, they range from developments in science and technology, sort of general trends, chemistry, chemical production and discovery, methods to disseminate chemicals in a harmful way, the science that's related to verification, which is quite relevant to this treaty as well, assistance and protection, chemical safety and security, and the value, and not just value, necessity of scientific literacy in decision-making for multilateral diplomacy. Here is our chair from last year, who's actually holding up this same brochure that I have some for you at the, off to my right. It's an executive summary of the report that was given to the states parties. And he's actually speaking to the states parties at their conference last year, saying, come up and get a free copy because this is the science advice that will help you. What is the actual purpose of science advice and science review? And that varies a lot. It could be horizon scanning, foresight. It could be to set policy for science. It could be to bring science into decision making so that the decision makers have the best possible scientific inputs that they need for the decisions they make. And how well it works is really dictated by who you're making your decisions, who you're giving your advice to. This is from a 2015 paper about the effectiveness of science advisors and science advice. And in the interest of time, I will just skip to the line that is International Organization Science Boards. You see green, that means these boards, because they have scientists from all over the world, they have credibility and are seen as independent. Where it's red, that's speaking to the highest levels of government at a national level. Not so great for an international board. And the yellow, which is hit and miss, is the influence of the advice from an international board on national policy. And that's really important because a treaty is about aspirations and obligations of states. The implementation of the treaty, and this treaty especially, is at a national level by implementation within the states that have the obligations. I show you this example of the Chemical Weapons Act of 1996 from the United Kingdom as an example of a national legislation document, and I picked this for a reason because it will come back later in the story unless I get cut off on time. Interesting thing about national implementation, when people talk about policy on science, setting policies, stopping science from being misused, that's often done at a national level because national priorities for policy on science dominate those discussions. It can be very difficult to reach consensus on policy for science at an international level. Advice also does not move forward quickly. For example, we have this database. It contains scheduled chemicals. These are the nasty chemicals we have on lists in the convention. Since the year 2000, the Science Board has been saying put unscheduled chemicals in there too because they're relevant to verification. And to show why they're relevant to verification, the diplomats get to see this really cool chart of mustard chemistry. And of course we say, look, anything without a red dot is unscheduled, therefore, and it's related. For years, this doesn't make any sense. Try to explain this in The Hague. But 2015, things change. That black mess there is impure sulfur mustard, and it contained, after chemical analysis was done, many of the unscheduled chemicals that are in this chart. And then we fast forward to 2017, and the states actually put together a decision and allowed for the first time, after 17 years of saying, we need this, to put unscheduled chemicals into that database. In other words, timing is everything on science advice. Some issues require much more immediate consideration. Since I've been at the OPCW, we've had 6 requests for intersessional advice from the Director General. They range from medical countermeasures and emergency response to molecular structures, which is a strange one, I'll come back to that, sample analysis, riot control agents, and new types of nerve agents. The sample analysis is quite interesting because think about the samples that are being brought together. You bring samples, you send them to different labs, maybe you get slightly different results in terms of ppm and ppb, even though the labs are saying the same thing. The policymakers will look at that and they'll say, how can we trust this? The labs are giving us different numbers. This report was all about understanding uncertainties in analysis. It's very important if you think about it, and I'll give you a high-profile example from several years before this report was written. A chemical analysis by the labs were given to then Secretary General Ban Ki-moon, and the chemical analysis that was in that report was also brought into discussions at the highest diplomatic levels. The result of this discussion saw Syria join the Chemical Weapons Convention and voluntarily give up 1,300 tons of toxic chemicals and chemical weapon agents. It shows you that chemistry and science can influence politics, but if you follow what's been happening in Syria since 2013, you will also know that science alone cannot overcome the need for diplomacy and policy. Other reports were about declarations and required immediate action. I will quickly go through how do you make this all work. Science will not change. Well, I shouldn't say that. Science will change. It will keep moving forward, which requires that science advisors need to think about the big picture. What are the driving forces and what does that change mean? And not get caught up with the hype that something might be used for nefarious purposes, but to understand what it can be used for and how it might be used. It requires engagement and credibility within scientific communities. That means workshops with the speakers to inform us of what's happening in the world across multiple scientific disciplines. Participation in conferences like this one, engagement with scientists on social media, and the publication of papers in peer-reviewed journals. And these 2 papers are really amazing because they have an authorship of scientists from 25 different countries, the Scientific Advisory Board. Bringing science advice to the states' parties, your science board, your states, your OPCW, who actually does the work when advice is taken forward. It's a director general, a diplomat, that facilitates that. We have a report that comes from the science board. The director general sends a report back to them, his response. There must be feedback and dialogue. That report is the translation into the policy world of what the science board is saying. The science board also needs to talk to the states' parties to tell them why they're giving this advice. In the case of the chemical structures, a pretty esoteric topic to be talking to diplomats about, we had to explain that to them using molecular models like you might do in a sophomore organic chemistry class. And at the end of the day, the UK came back to us a few months later and said they had modified their Chemical Weapons Act to reflect the advice about the nuances of chemical structure because it actually impacts declarations. Science advice should also provoke discussion and provide new ideas. We talk a lot about recognizing biochemical change, which is not exactly coming from the sectors of traditional chemistry. It's not so different than the IMS, recognize unusual events, as opposed to try to recognize what's happening in science that you're worried about. We talk about forensic techniques to identify nuances in samples to give us some indication of how that sample possibly was made. And it turns out when you provoke the states' parties to have this discussion, you remind them that the convention actually says we should be talking about verification. Of course, when they respond to this, they say verification should be made more effective, listen to the science board, but they have these 2 words, as appropriate, which is they're out. In the end, it looks like we're talking about science, as you can see from this OPCW-themed periodic table, but in reality, you're dealing with delegations who have national views and national positions. I will wrap up here with one quick whirl-through of recent science advice on another controversial topic. After the events in the UK last year, the Science Board did a report on new nerve agents. Decisions were put forward by states parties. The first time in 26 years, it's possible that we may be changing the schedules of chemicals of the Chemical Weapons Convention. And all of a sudden, we had diplomats talking about molecular structures in the Executive Council. We had to teach them, or not, I shouldn't say teach, we had to explain to them what is actually on the schedules. We made an augmented reality chemistry quiz. There's copies of it over there if you like. We talked to them about not complicated chemical names, but actually understanding the language of chemistry. We talked to them about what it means to have multiple carbon atoms, which they argued about. That's the ambassador of Austria in yellow to the Netherlands playing with molecular models. And we created a very unofficial science for diplomats version of the chemical weapons schedule list, which has molecular structures, and if you can get the online copy, it actually allows you to interact with these things in 3 dimensions. So you also need support, a facilitator, and money to do this, and I will stop on this slide and basically say I've told you a number of things, probably quite quickly, about how a science advisory mechanism works. But the most important thing is the communication between the science advisors and those getting the advice. And the next most important thing to realize is that science is but one dimension of policy and decision making, and it doesn't always override the final decision. With that, I will stop here, and thank you for your attention.
Thank you, Jonathan. So the good news is he will be one of the speakers on the panel that starts at 1700, and so hold your questions for him then, and we will move on to the next speaker.
The next speaker is Afira Firdaus from the Center for International Strategic Studies in Islamabad. Welcome.
Thank you. Ladies and gentlemen, good afternoon. I'm Afira Firdaus, Research Assistant at Center for International Strategic Studies, Islamabad, Pakistan. Before I start my presentation, I want to say that the opinion in this presentation is my own. It does not represent any government department of Pakistan or my organization. Basically, the research topic of my presentation is comparative analysis of CTBT with different nuclear and non-nuclear arms control and non-proliferation treaties, and limitations and strengths. Here comes the outline. There are 3 basic parts in this presentation. First, comparative analysis, as I said, with treaties like PTBT, CWC, and NPT. Second is challenges to CTBT currently and opportunities ahead. While thinking about arms control and non-proliferation treaties, for most questions that come into the mind is that what necessitated arms control and non-proliferation measures. Basically, 1950s and 60s, notable high-yield nuclear tests became primary motivator for arms control and non-proliferation measures. For example, in 1954, the US conducted a nuclear test named Castle Bravo under sea surface. The bomb was designed to have a yield of 5 megaton of TNT. However, due to unexpected complex reaction in lithium-7 isotope, it had yield of 15 megatons of TNT, which resulted nuclear fallout with severe effects. This test led to counter-test by Soviet Union in shape of detonation of Tsar bomb in 1963 with the yield of 50 megatons, 6 times more powerful than Castle Bravo. Aftermath of this test caused the designer of Tsar bomb, Andrei Sakharov, to propose ban on nuclear weapon testing above land, undersea, and in outer space. The proposal generated public debate and later political will among states such as US, UK, and Russia to negotiate such a treaty, which led to negotiation and entry into force of PTBT. So coming to the basic part of this presentation, comparative analysis of CTBT and other treaties. There is another important question that why treaties such as PTBT, CWC, and NPT are more successful than CTBT. There are multiple answers to this question. First of all, if we specifically talk about CWC, its comprehensive approach, due to its comprehensive approach, it is more successful than CTBT. These treaties have better built-in mechanism and have norm-based consensus. In this section, I will discuss similarities and dissimilarities between these treaties and CTBT. Coming to PTBT, Partial Ban Treaty, also known as Treaty Banning Nuclear Weapon Tests in Atmosphere, in Outer Space, and Underwater. Paragraph 1 of paragraph B of PTBT became rationale of conception of CTBT. Unlike CTBT, PTBT did not outline any inspection methods for state parties, nor any method to enforce any sanctions in form of violation. PTBT remained intact, hinging on goodwill of state parties. PTBT became redundant after the signing of CTBT, but it will remain enforced for states who did not join CTBT. There is a shortcoming in PTBT that it failed to prevent the execution of nuclear weapon testing in garb of PNEs, that is, peaceful nuclear explosions, as long as they were underground. Indian nuclear tests in 1974 are first of its kind of exploitation of PNEs, which enabled horizontal proliferation. CWC, as I already mentioned, that it has comprehensive and all-inclusive approach, and it almost accomplished disarmament goal of chemical weapons. The treaty remains successful because of its built-in mechanism and norm-based consensus among its state parties. It completely rejected horizontal and vertical proliferation of chemical weapons. CWC and CTBT has structural identical nature with two different focuses and objectives. These have similar verification and compliance mechanism and similar kind of executive and technical secretariats. Both treaties enforce national authorities as implementation organization in state parties and some other things like that. But CWC is considered to have maintained confidentiality of data of state parties in better way than CTBT. Nuclear Non-Proliferation Treaty. The main objective of this treaty is to prevent horizontal proliferation, but it struggled to prevent vertical proliferation among nuclear weapon states and horizontal proliferation among non-nuclear weapon states. In a special case of giving NSG waiver to India by a state, NPT state, the purpose of NPT is also weakened by providing opportunity of horizontal and vertical proliferation. So, contrary to CTBT's objective, manufacture of a simple nuclear weapon is still possible and will remain possible, devoid of testing nuclear explosions. So mainly the major objective of CTBT, that is ending the nuclear testing, is not the fundamental objective of NPT, that is preventing manufacture, attainment, and possession of nuclear weapons. It is critical to analyze the challenges that CTBT stands confronted with. There are ongoing efforts by certain states to modernize nuclear forces. In absence of nuclear testing, states continue to proliferate nuclear weapons through their respective custodianship and stewardship programs. Custodian program of states allows them to replace their nuclear weapons and their critical components, even if there is no evidence requiring such a replacement. Likewise, many states have their stewardship and management plans still working, though it needs proper authorization to replace nuclear weapons or its critical components. Second point, critical point of CTBT is that formalization of Agreement 123, that is Indo-US nuclear deal, has proponents of nuclear proliferation on their toes. The deal allows India, despite being non-NPT state, to engage with nuclear commerce with NPT member states, many of whom also have ratified CTBT as well. Despite being a non-NPT state, under the deal, India is allowed to separate its civil and military facilities. The deal also helps India to build strategic reserve. This deal accounts any eventuality if India may need to conduct nuclear weapon in the future. In that case, the US reserved the right to withdraw, though the process of withdrawal is very exhaustive. But the other NPT, countries, NPT or CTBT states, may continue to provide India nuclear fuel. So indirectly, the very purpose of and goal of CTBT could be compromised by the state that may have ratified CTBT. Coming to the next point, that is security-driven concern. Intrusive and non-intrusive scientific measures of inspections and verification will go only as far in the ensuring compliance, as long as the cost to conduct nuclear weapon tests are considered relatively lower and incentivize addressing a cited security-driven concern of any state. This is perhaps one of the major reasons why states are motivated to undertake nuclear testing to achieve nuclear deterrent capabilities. This approach may help satiate the need for addressing a security-driven concern, though it can also lead a region into arms race, as it was evident in the case of South Asia. Indian evasion to sign CTBT during 90s reinforced the action-reaction cycle in region, which led Pakistan to remain on sidelines given its own sidelines to CTBT, given its own security stand jeopardized in absence of credible nuclear deterrence. Under Article 8 of CTBT, a state may require permission for review conference to conduct underground nuclear explosions for peaceful purposes. The review conference decides by consensus of state parties to CTBT that the request may be permitted or not. If history is to serve as a prelude to future, one state had already exploited PNEs, that is, peaceful nuclear explosions, in 1974. Next, much debated critical point of CTBT is computer simulation. A plausible alternative to nuclear testing for nuclear weapon countries is to resort to use of computer simulations or cold tests in order to study, predict, and evaluate the behavior of nuclear weapon explosions in absence of nuclear testing, as there is no ban on computer simulation under CTBT. With advances in AI, including predictive and machine learning, simulation codes can be developed correctly, and it would be possible to predict nuclear weapon test performance precisely. Though I have talked much about challenges to CTBT, but the picture is not that grim and dark. There are some opportunities ahead. North Korea IMS detection system and its performance during North Korea's nuclear testing appeared as CTBT's strength. IMS detection capabilities may deter other countries to conduct nuclear weapon testing of low yield in the future. The added value of IMS data for disaster mitigation became evident in Japan's disaster, as seismic and hydroacoustic stations enabled national tsunami warning centers in the region to issue timely warnings. Also, radionuclide stations provided first-hand information on the emission from a stricken power plant and its dispersal worldwide. The importance of IMS data in the field of climate change has also become more evident currently. I'll conclude my discussion with 2 points. That there is a need for more integrated and comprehensive approach for arms control and non-proliferation or disarmament treaties. These treaties are not successful majorly because of lack of political will and commitment on behalf of major proponents of disarmament who already have attained nuclear weapons as well. Thank you.
Fira, maybe you could stay up on the podium for a moment, and maybe you could take one question. We recognize that we're standing between you and our coffee break, so maybe we can just take one, yeah, about that.
The mic is coming to you.
I need to say a little housekeeping thing.
Hello, my name is Ardalan from CTBTO. I thank you for your presentation. It was quite comprehensive. I just have the feeling that I failed a couple of points to understand them. I mean, first of all, you were talking about the success of the CTBT. Somehow compared it with the other treaties like PTBT. I really didn't get the measure of your success. I mean, what makes you think that PTBT was more successful than CTBT, as one? And the other one is, as one of the challenges you listed was about computer simulation. How do you see the computer simulation as a challenge to CTBT, thinking of the fact that it's not even addressed in a treaty per se?
Okay. About your first question, PTBT is successful in my opinion, that because of its entry into force and after more than 20 years, CTBT is still struggling to on this front. And secondly, second point was about computer simulations. Yesterday, someone was talking about the large amount of data of already conducted nuclear tests in major countries like US, Russia, and China. More than 2,000 tests was conducted before CTBT, negotiation of CTBT. So that data can be coordinated with AI and machine learning, and that can be very much helpful to predict the behavior of any nuclear testing without nuclear weapon performance, without testing a nuclear weapon. So why is CTBT preventing countries to test nuclear weapon? Because it want to discontinue that. Continue that course. So if, despite ending testing of nuclear weapons, computer simulation is already serving that matter.
Okay, thank you very much. Just before we go, we will resume at 4:30 with the third of our oral presentations under this theme. Just to recall that within the app, there is a function for voting for best presentation and also for best poster. We will have a poster preview session a bit later, so please do look at that and keep in mind the presentations in this session. Thank you.
Okay.
Sure, and then you'll hand it over to Malik in that case. Ladies and gentlemen, you take your seats, please. I trust everybody is well caffeinated after our coffee break. I'd like to briefly introduce our next speaker and final speaker for this session, Dr. Edward Ift from Stanford University. Please, you have the floor.
Thank you very much. This feels like a rather grandiose setting for one rather modest presentation, but thank you for coming. Negotiations with North Korea, in particular over its nuclear weapons program, have started and stopped several times over many years. The Trump administration has initiated the latest attempt after a promising start, which appeared to include reasonably businesslike and even cordial relations between Presidents Trump and Kim. A deadlock has taken hold. Moving forward would be facilitated by applying certain lessons learned in earlier arms control negotiations, some of which encountered problems similar to those now frustrating both negotiators and observers. Hopes that this time will be different rely primarily on several new developments. First, the sense of heightened danger, especially to the U.S., created by North Korea's successful series of nuclear weapon tests, plus advances in creating long-range ballistic missiles, has led the U.S. to seek such an agreement. This is in contrast to President Obama's policy of strategic patience, which basically failed. President Trump, of course, is given to seeking bold moves and prides himself on his negotiating prowess, and success in this area would be a major accomplishment. Second, South Korea's President Moon seeks to end or at least ameliorate decades of hostility with a highly militarized and impenetrable border artificially dividing the Korean peninsula. He seems willing to take initiatives and assume some risks toward this end. Third, it is difficult to understand fully the motivations of President Kim and his isolated hermit kingdom, but he appears to be somewhat satisfied with having reached a sort of military technical plateau in the nuclear and ballistic missile areas. In his eyes, this may provide some level of security from outside interference and attack. It may also provide some bargaining material for him. By giving up at least some portion of his nuclear weapon and ballistic missile programs, along with adopting a less confrontational stance, he may well see an opportunity to gain relief from sanctions, a more productive relationship with South Korea, a formal end to the Korean War, and to achieve a more normal position generally in the world. Conventional wisdom over the past 20 years, which I think is probably shared by most people in this room, is that North Korea will be a hard case for the CTBT and might well be the last to join of the 8 countries whose ratification is required. Now, perhaps that pessimistic assumption is no longer valid for the reasons which I just gave. It makes no sense for North Korea to say it's giving up nuclear weapons, but at the same time to insist on the right to test nuclear weapons. We should push hard on this point. Obviously, this is awkward for the United States, which has not ratified the treaty, but others can press this, and the friends of the CTBT are doing this. Dr. Zerbo, writing in the Arms Control Today of last November, wrote, quote, "The path to the verifiable denuclearization of the Korean Peninsula runs through the CTBT," end quote. There are some important lessons we can use from previous negotiations. We have a lot of Korean experts, and their contributions are very valuable, but many of them have little experience with these earlier agreements. So, in the limited time available, I'm going to briefly run through what I think are 5 lessons relevant to this negotiation to be learned. First, on terminology. There are a lot of high-level documents, and all the parties affirm this, including UN documents, which say that the goal is, quote, denuclearization. I understand I'm tilting at windmills here, but I'm just going to say it. Denuclearization is a very poor term for what we are trying to do. And the new formulation, complete denuclearization, is even worse, in my view. Part of the problem we have is that a lot of the articles that I read seem to assume that whatever constraints are negotiated are going to apply only to North Korea. This is not true. They will also apply to South Korea. The Singapore Summit joint statement calls for, quote, the complete denuclearization of the Korean Peninsula, end quote. So, do we intend to ban civilian nuclear reactors from the Korean Peninsula? The Moon administration is hoping to phase down nuclear power, but South Korea gets nearly 30% of its electricity from nuclear reactors. Something like 24 nuclear reactors are operational. The 1994 US-North Korea agreed framework called for 2 light water reactors with substantial help from outside countries. Russia is talking about building reactors in North Korea. Do we intend to ban nuclear medicine for cancer treatments from the Korean Peninsula? Medical isotopes, of course, can be used in dirty bombs. I think not, but that would be the plain reading of the words complete denuclearization. There's been a lot of hand-wringing of the fact that there is no agreed understanding of these words, complete denuclearization, among the US, North Korea, and South Korea. It's not even clear, I think, what each of these 3 countries themselves mean by that term. It's likely that a lot of time and energy is going to be wasted on this dispute with a solution based on this formulation, in my view, unlikely. We can learn from the US, USSR, Russia experience in SALT and START. We have negotiated successfully for over 45 years on strategic offensive arms without ever reaching an agreed definition of the term strategic. We've put a great deal of emphasis on definitions. There are 124 definitions in START 1. There are 90 definitions in New START. You will not find a definition of the word strategic in either one of those lists. So the sides early on recognized that trying to get an agreed definition of strategic was hopeless. And so we simply moved on and agreed on what systems could be constrained and how we would constrain them. I see a parallel between the word strategic and the word denuclearization. Both words were agreed at the presidential level, with unfortunate negotiators left to try to figure out what the words mean. And perhaps we don't need to define that. In my view, our goal should be to create a WMD-free zone on the Korean Peninsula. It seems elementary to me that the fundamental core of the overall agreement would be that both Koreas should be parties to the Big Four: the NPT, the CTBT, the CWC, and the BWC. South Korea is already a member of all 4. Curiously enough, the US has not said that it's important for North Korea to join these 4 treaties. Perhaps that's due to the disdain of the Trump administration for large multilateral agreements. However, if you think it's okay for North Korea to have chemical and biological weapons, Or if we can't negotiate that, then the goal should be a nuclear weapon-free zone on the Korean Peninsula. There are 5 of those in the world. We know how to do that. To that, we would add whatever constraints we can get on ballistic missiles and fissile materials. In that less ambitious case, the relevant treaties would be, of course, the NPT and the CTBT. All of North Korea's key neighbors, South Korea, China, Russia, and Japan, are members of these agreements. And North Korea could also join the ban treaty, of course, if it wanted to do that. Secondly, the step-by-step approach. In view of the deep mistrust between the sides, I think it's obvious that the solution is going to have to be a step-by-step approach, but this has become a big issue. With so many trade-offs involved of unlike things, a mix of technical and political issues, warheads, facilities, testing locations, sanctions, information exchange, end-of-war declarations, economic incentives, et cetera, it's obvious to me that things must happen in stages. Either we have a series of agreements or one big agreement implemented in stages. Next, the question of test tunnels. As you know, on May 24th of last year, North Korea closed the entrances to its test tunnels at Punggye-ri. The British AWE presented an interesting paper on that here yesterday. There was immediate uproar that North Korea had not invited international inspectors to view this. It's not clear who these international inspectors would be. Technically, the CTBT does not have inspectors. The IAEA does, but not for this purpose. Certainly, the CTBTO could put together a team. I suppose you would want mining engineers and geophysicists to go look at the tunnels. But I would make the point that the procedure which the North Koreans used, which is high explosives to collapse the roof of the tunnels and close the entrance, is the same as the one used by the US to close 181 tunnels at Degelin Mountain in Kazakhstan under the Cooperative Threat Reduction Program. I was there when the last tunnel was closed. It was a huge celebration. The US ambassador was there, a lot of high officials from Kazakhstan. Nobody thought that wasn't good enough. Of course, the circumstances were different. The point is, closing of the tunnels was not required by any agreement. It was purely voluntary, and I would think it should be welcomed. Of course, North Korea could reopen those tunnels. Of course, North Korea could dig new tunnels. Of course, there might be other tunnels there that we don't even know about. The point is, all 3 of those are perfectly legal under the CTBT. Even after entry into force of the CTBT, nobody is required to close a test site or to close tunnels. As you know, the US and Russia are still using their former test sites for hydrodynamic experiments. Only France has permanently closed its test site. If required later by agreement, it seems to me it would be a simple matter to verify that the tunnels are closed and there are no other adits there. So, if the proposal is to impose on North Korea a regime more strict than is in the CTBT, that sounds to me like a difficult negotiation. But one could quote President Trump, we'll see what happens. Data exchange. After the failed Hanoi summit, there was outrage, at least in Washington, that North Korea had not provided a complete list of all its nuclear facilities and assets. Of course, establishing an agreed baseline of what exists now will be very important at some stage. Secretary of State Pompeo made a speech in which he said that this complete accounting by North Korea must be the first step in the negotiation. Again, no existing agreement requires this. And again, START and New START seem to me the best model. In the START Treaty, the Memorandum of Understanding, which is where the big data exchange takes place, required a long negotiations. That document was over 100 pages long, and it contained all the relevant facilities, the inventory of assets, technical characteristics, site diagrams, photographs, geographic coordinates, et cetera, et cetera. When I last checked, the two sides had carried out something like 17,000 notifications between Washington and Moscow under New START, keeping this database up to date. So the sides agreed on all that, but, and here's the key point, the actual data was not exchanged. That is, we filled in the blanks late in the negotiating process when both sides were assured that all the key issues had been resolved and there would be a legally binding agreement. Why would Kim provide all this information now? To be crude about it, this would be telling the Americans where to drop the bombs and where to send the Marines. Why would he do that in exchange for nothing at all? So people should get busy and work out what information will be exchanged at the appropriate time. Finally, past actions. I foresee that this is going to be very controversial, forcing North Korea to account for its past actions. South Korea is cited as a desired model. Indeed, they were very transparent and cooperative, but that was a small program, and it took the IAEA years to confirm its accuracy. We should take some lessons from Iraq and Iran, where attempts to require a full accounting failed with disastrous results in the case of Iraq. Certainly, it would be useful to have a full accounting from North Korea, in particular of its violations of the NPT and UN Security Council resolutions. But we should not let an inability to achieve this stand in the way of agreement on future activities. There are many successful examples of individuals and corporations who refuse to fully explain or admit guilt for past activities, but agree not to conduct such activities in the future. I'll stop there. Thank you very much.
Our poster preview session is starting in a moment. Those who have submitted posters for this, if you haven't yet seen the ushers over here to my right, please do so. We have got a few very short minutes for questions on this oral before we move to that.
Does anyone have a question for our last oral presenter? Okay, well, I imagine that Edward will be around if you do find him and want to ask. But we do have to move on to the poster session preview as well. So, Cormac.
Okay, our presenters are ready. Are the posters lined up? The poster preview session will run now. We, I believe, have 3 that have been submitted. Each of those presenters for each poster will have 1 minute to give a brief description of the poster. These posters are all available for viewing today only. They will be replaced tomorrow. So I do invite you to go and have a look at them later when you have a chance. And just a reminder again that we do have on the app, on the mobile app, the function to vote for best poster. So please keep that in mind, and best poster preview as well.
Good afternoon. My name is Ardalan from CTBTO. Together with Jenny Nielsen, we're presenting this poster. The essence of it is quite simple. When we're talking about science diplomacy, nowadays it has a well-established taxonomy of different dimensions of science for diplomacy, science in diplomacy, and policy for science. Now, the thing in the literature, whenever we're looking at, is that there are examples for each one of these dimensions, so separate examples. And the idea that we're presenting here is that we could find larger, more comprehensive examples, more complex activities, which we claim represent all different facets of science diplomacy. And we took the on-site inspection as an example over here, being a quite complex operational and scientific activity, having in mind all its different dimensions and facets.
I think that we've already come to the end of the.
Is it over?
It's on a loop, and it will just move on, I'm afraid. But you can go and see the poster in all its glory in the room behind us here.
So, thank you. Come over to the poster, visit us. Thanks.
I named my title Arms Control Research, not Arms Control, because it is a meta-analysis on arms control research. I gathered highly regarded 2,600 publications on arms control and found interesting trends. The figure you are seeing on the screen is one of 8 findings on my poster. If you would like to know more about which fields, countries, organizations, and universities study arms control and their co-authorship, who the top 30 authors are, when it began, and how it evolved, please join me. Thank you very much to those who has already stopped by. Your comments are all well taken. I'm looking forward to seeing more of you today. Thank you.
Okay, that's it. Actually, just two posters at the end. Okay, so thank you very much for your time. Thank you to my co-moderators. Any last words?
No, just a special thanks to CTBTO and our panelists, or maybe a round of applause for them. Thank you.
Okay, that was easy. I'm a sort of scientist.
And as an engineer, I have to say, I'm only dealing with inspection. I've heard of it over the years.
Yeah.
So I took the liberty of just sort of taking a brief look at the Wikipedia entry for it.
Well, it has a reputation of being very conservative, which it is, on things like healthcare and tax bills. But you've got George Schultz, who's
Perfect. All right.
Good afternoon. So before we have this panel, there is a brief presentation, which is one of the scientific presentations in the Book of Abstracts by Ted Boyer of the Pacific Northwest National Laboratory. He's also the chairperson of the radionuclide expert group in Working Group B of the PrEPCOM. And he will give you a talk about backgrounds and false positives dealing with radionuclide detections in 2019 and beyond. So please, Ted.
Thank you, Martin, and thank you, dear colleagues, for attending this meeting. I was surprised about 6 months ago when I was asked, could we just live with the backgrounds that we have? And to me, that meant that we needed to better explain to people what we mean by backgrounds and the implications of living and not dealing with backgrounds. And so that's what my presentation is going to be about. So I wanted to start by explaining in, I guess, CTBT terms, in the case of the IMS, what a background really is. And for us, background refers to the fluctuating concentration of airborne radioisotopes in the environment that are not associated with a nuclear test. Now, this could be either isotopes that interfere with our measurement, or it can be the actual isotopes that we are keyed on for looking at. And I'll explain that in a little bit more detail later. But it is important to note that backgrounds make our job very difficult in the IMS, in the radionuclide community. Sometimes it makes it impossible for us to interpret our measurements. As an example, the plot at the bottom of this slide in blue shows the concentration, that is the blue trace, as a function of time at a real IMS station. And so non-technically, you can see it's bouncing up and down every day. And while we haven't had that many nuclear tests. So we have to somehow detangle that background, that concentration of that isotope, from isotopes that could come from a nuclear test. Well, what does this look like globally? The last view I showed you, and I will come back to it in a second, was for a particular station, one single station, that commonly saw radioisotopes that are interfering. But it's also a global problem. What's shown here, and this is a nice plot calculated by Pascal Hakim from CEA, which calculates the average concentration of a particular isotope of, in this case, xenon-133, which is one of our most important isotopes to look at. The other thing to note is that the red, purple, orange, and yellow are levels that are easily detectable by the IMS. So you can tell from that single plot that the various sources that we know about can create detectable levels of xenon-133 across the entire globe. So, does that mean that we're done? We all go home early? Well, luckily, no. And that is, if we have some knowledge of the background, we can do something about it. Unfortunately, the backgrounds change every day at a station, sort of like weather changes every day at a particular location. So we have to do something a little bit more than look at averages. We can subtract the effect of the background if you have one of three pieces of information, and I have them listed there, and these are in order of how well they work. First is if you have the knowledge of emissions from a particular source of interference, and I'll explain that in a second, you can subtract off the effect. Second, if you know the average local background, you can do somewhat of a job to remove the effect of the background. And third, if you're making measurements at that station every day, you do get some, again, average sense of the amount that needs to be subtracted. But the last two bullets can only be done in an average sense and really are not going to be useful for verification. So now back to my first bullet, which was if you had some foreknowledge of the amount of isotopes emitted into the environment from a particular source. I have that shown in this picture with a blue facility, which is an emission source, and a typical emission source on Earth for the isotopes that we care about may emit in the range of 1 with 12 zeros, 10 to the 12th atoms in a single, 10 to the 18th, sorry, 10 to the 18th atoms in a single day. Now, that can be transported by the wind, and that can show up at an IMS station, and those IMS stations detect as little as in the range of 10,000 per day. But the important thing is, if you know the number, which I've shown in green, which in this case is 1 with 18 zeros, you should be able to calculate with some fidelity the amount that should show up at that station through atmospheric transport models, which you've seen a lot of those calculations today, including from Michel Jean in this room just an hour or so ago. So we can predict the effect at the IMS station. So here's an example of how we would do that. Shown in blue is the same plot that I've shown previously. That's real data from at a real IMS station. And what's shown in red is if you had knowledge of the emission at an industrial source that caused the blue curve, you could subtract it off with some precision and you get the red curve. You can see it dips below 0 sometimes. It's not always at 0, but that's as good as we can currently do to subtract off the effect. So with no knowledge of the background, you get that blue curve. It looks like there's many nuclear tests. If you had some knowledge and can do some calculations, you get the red curve, which is obviously much better. Back to my original question. What can we do if we cannot correct for the background? Well, we get one of two things, and that is a false negative or a false positive. And I'll explain that in a second. Well, a false negative, first, as far as definitions goes, a false negative is when we miss something that could have been a nuclear test. So it's essentially masked by the background at the station. A false positive, and I'm going to go into a little bit more detail about that, is we may think something's a nuclear detonation when in fact it's actually just a peaceful source. So we see we can't do nothing because we'll get false positives and false negatives. So going into false positives, accidentally saying it's a nuclear explosion when in fact it isn't. Well, what does that happen? What happens if that's the case? I think everybody has their own imagination. I jotted down a few things myself. Well, obviously it's going to cause difficulties for all state signatories. Among other things, you could call for, or a state could call for additional scrutiny on samples, physical samples that were collected at IMS station. There could be calls for reanalysis of the data from the IMS station. All of that costs money, costs time, and is a pretty stressful situation. Ultimately, there could be calls for on-site inspections. And this is all could be because of backgrounds at a station. And I'll explain why I think this is such a big deal. Well, how might a false positive happen in reality? Well, I'm not a seismologist, but my seismologist friends tell me there are tens of thousands of seismic events per year, depending on how you define an event, most of which are screened out and determined to be not explosive in nature for various reasons. However, if there's a seismic event that occurs at the same location and time as you have calculated the IMS, as you have calculated the radionuclide emission from, well, that's going to be a lot more important. And someone might get upset. And there might be a call for an on-site inspection, et cetera. So we've calculated the probability of this happening at the former Nevada test site, which is now called the Nevada Nuclear Security Site. We calculated the probability that this would happen. So in the next few slides, it's a notional situation. It didn't really happen. But what we've calculated is what's the probability that there's a seismic event at the Nevada test site, and if there was a source of radionuclides at different locations in the US, what's the probability that it would look like it actually came from the Nevada test site when it didn't? I know the seismologists will say, hey, well, we have our own tools, and it's unlikely that we will misidentify it. But the reality is, it still can happen. Enigmatic events have happened in the past, and we expect that they could in the future as well. So our model for false positives is, now I'll try to do this slowly because it's a little complicated. We have assumed that there was medical isotope production in the middle of the state of Utah, okay? And we've also assumed that the existing IMS stations that are there are detecting emissions from that isotope production facility. So every day we can calculate where did that emission come from, and we could calculate that it came from Utah, or we could calculate that it came from California or some surrounding state. And what's shown in the color is what's the probability that the plume passed over that state. So in the case of Utah, since the isotope production in our hypothetical case was Utah, it's most likely that the plume came over Utah. That makes sense, right? Or from California, prevailing winds are from west to east, so that makes sense. So a couple of times per month, the surrounding states look like the emission came from those states, but most of the time it looks like the emission came from Utah. And so now, again, this is now graphically, if we had an IMS station in this case in Ashland, Kansas, the production was in the center of Utah, but our calculation about the location is imprecise in the case of atmospheric transport modeling. So it could have looked like it came over the Nevada test site. We did some simple statistics and calculated the overlap in time and space. And what we determined is the probability of an earthquake at the Nevada test site overlapping with our calculated location, if there was isotope production in Utah, is 84% chance in 1 year. So if you had isotope production, you expect almost every year that you're going to get a seismic event and a radionuclide event that look like it came from the Nevada test site. Now imagine that as a general case across the world. There's going to be many times where there are seismic events and radionuclide events that overlap, and there will be a concern by people that that actually was a nuclear test. It turns out, just as an interesting thing, there's only one state in the United States where the probability is 1% or less, and that's Maine. So this is and the United States is a very big country, so you can imagine this is a very big effect. So in conclusion, it is very likely this will happen. It won't be a small chance. It will happen often. And we do need to do something about it. We need to characterize backgrounds. Luckily, I will say that the existence of backgrounds was anticipated during the writing of the treaty. That didn't come as a surprise to us. The thing that did come to as a surprise was how large and widespread it was. So the treaty actually does have language allowing us to measure backgrounds. We need to measure backgrounds and understand them. But without doing that, without being able to subtract off accurately the effect of background, there's going to be a significant chance of false positives in the IMS. And that's, I think, something that we all do not want. Paying attention to this problem, we can largely mitigate the impact at the IMS stations. And there's been other talks and posters that you should look at if you're interested in this problem. Thank you.
Maybe we can entertain one or two quick questions. Is there any? The purpose of this presentation is to give an example that is relevant for policy advice from a technical level to a national authority, from a national data center, for example, on a CTBT relevant issue. And the panelists and the discussion later can refer to the example given by Ted in the discussion. I don't see any question right now, so we can proceed to... Is there any? I'm sorry. Yes, please.
How difficult would it be to put a measurement device near all the isotope production plants of significance in the world?
I didn't hear it. It was echoed.
Can you repeat, please?
How difficult would it be to put measurement devices near all the isotope plants in the world?
technically very simple. And in fact, there is a project called the STACS project where that is being pursued. There are posters, and there was a presentation on the STACS project earlier this week. So technically very simple to do. There's lots of details, though.
Okay, I think this is it.
Done?
Yeah. Okay. Do you see another question? No.
I do not.
Okay. So also for time reasons, let's move on to the panel. So now the panel discussion on science diplomacy, science advisors and arms control practice, improving policy implementation through technical expertise.
Well, thank you, Martin. Thank you, Ted, for that presentation and leading us off with a concrete example of how complicated data needs to be considered by policymakers, and we'll explore that in a lot more detail in this panel. So my name is Millette Mespin. I'm the director of the Center for Science Diplomacy at the American Association for the Advancement of Science, or AAAS, and I'm honored to be here today to help moderate what I'm sure will be an interesting discussion. But before we start, I first want to commend and recognize Dr. Zerbo and the entire CTBTO organization for their efforts to embrace science diplomacy in their work, not only in this meeting, but also in a biennial meeting that they hold on the topic. Many of the speakers in yesterday's session, the opening sessions, noted, we are in an increasingly complex time in our world, ranging from the politics to dealing with the impacts of things like climate change. And the involvement in scientists is essential in coming up with the solutions to those problems. And so the need for science diplomacy is really only growing. When we talk about science diplomacy, we often use a framework that AAAS and the Royal Society developed in 2010. It's a three-part framework: science for diplomacy, diplomacy for science, and science in diplomacy. And there's really no greater illustration of the role of science in diplomacy than in the area of arms control, from how scientists, scientific evidence, and scientific advancements have played a role in diplomatic efforts and outcomes. In fact, while science diplomacy is a term that might be relatively new in the public consciousness, the practice in the modern era really grew out of a lot of the post-World War II conversations related to the US and Soviet scientists all around arms control issues. And so in science diplomacy, we often look at the past and examples to help us understand and see how science and scientists have been able to drive policy change, impact international relations, and influence diplomatic endeavors. And in arms control, those numbers of specific examples in that area are great, from the Antarctic Treaty to, of course, the Iran nuclear deal. We focus on the universal nature of science as being really a common and neutral foundation for policymakers and diplomats, even in issues and in relationships that are contentious. How that can be a common ground and common foundation, and the role that science plays in building trust. And finally, we think about understanding the possibilities of science diplomacy through looking at the successes and the failures, the similarities and differences in other areas that help to serve as examples for us to follow. So CTBTO was absolutely right to pull together this panel, and we'll touch on several of these ideas and really have a broader discussion about policy and diplomacy in areas related to arms control that can be advanced through scientific advice, technical solutions, and examining verification regimes. So the hope is that we'll learn from these practices and these experiences to apply to approaches that are relevant for specific issues related to CTBT. So our panelists today each bring a diverse set of experiences to this stage today, from national to multinational perspectives, multiple sectors, and all regions of the world. This session will start by each of them giving overall thoughts on the topic, and then we'll launch into a discussion around the themes of the panel, and then open up for questions. I am going to try to use this app, and so if you, in the course of the panel, have any questions and you want to just write them before we get to the general Q&A, please feel free to do that. But let us begin, and I will introduce each panelist before he begins. So we'll start with Jonathan Foreman, and hopefully all of you heard his excellent oral presentation in the last session. But he is the Science Policy Advisor at the Organization for the Prohibition of Chemical Weapons, or OPCW, and Secretary to OPCW's Scientific Advisory Board. His career combines providing scientific evidence on the impact of science and technology change to decision makers at OPCW and driving product development in biotech startups. So we'll turn it over to Jonathan.
Okay, thank you very much for a nice introduction. I have a couple of slides because I think I heard this yesterday that I feel better when I have slides, otherwise I get nervous when I talk. Do we have on screen? Okay, maybe. Well, I can, while we're waiting. So I just wanted to say a few very brief words that follow the talk that I gave at 3:30. We have a disarmament treaty. We talk about science advice for a disarmament treaty. And the people that actually are involved in doing the hands-on implementation of the treaty are themselves very technical people, which begs the question, aren't they qualified to give science advice as well? But the reality of the treaty organization is that the decisions to use certain scientific advancements or to take scientific dimensions into decision-making happen by delegations from the states parties or our Director General, a high-level diplomat. There's a need to merge the two worlds to bring science into the discussion. I showed this periodic table of the states parties of the OPCW. It looks like chemistry on the outside, but if you look deeper, this is reflecting bringing our states parties into chemistry. On the other hand, this can't be a one-way discussion, so there's a way that we need to bring chemistry into the conference room to talk about science and get them to understand the science, have enough scientific literacy to make good and qualified decisions. And the point that I'd like to make with all of this is you can have the most accomplished diplomats and you can have the most brilliant scientists, but if they can't find a way to communicate, it doesn't matter how good the science advice is, it won't get taken up. So with that, I'll turn this back to the panel.
Thank you. We will move to Mansung Yim, who is currently at Korea's Advanced Institute for Science and Technology, or KAIST, where he is Associate Vice President of the International Office and Director of Non-Proliferation Education and Research Center. He's had faculty and research positions at various institutions in Korea and in the United States, and served on scientific advisory boards and committees at Idaho National Laboratory and for the Republic of Korea. Man.
Thank you, Marlet. It's a great privilege and pleasure to be able to speak in this panel. So my, I guess, assignment for this particular session at this point is, how does the scientific and technical advice help assist CTBTO signatory country in their policy making? So as you know, South Korea is right next to North Korea. Our neighbor North Korea has tested nuclear weapons for 6 times. And South Korea is a member of CTBTO, is a operator of one of the IMS stations. And as Korea Institute of Geoscience and Mineral Resources, SNDC. And IMS has provided key information to determine the size and yield of North Korean nuclear weapons. So far, the 6 nuclear weapon tests conducted by North Korea, starting in 2006, with the latest one in 2017, has been tested using the various information, including the best practices from our neighbors and other IMS stations in terms of radionuclides released and the seismic activities and then the size of the bomb. These information become very critical pieces of information, become the basis of policymaking in terms of understanding how North Korea is moving in their development of nuclear weapons capability. As you know, the first one, 2006, October 9th, we know it is about 1 kiloton bomb, maybe not a successful one, but with the plutonium. The second one was maybe a successful one with same plutonium, but had a larger yield, 2 to 7 kiloton. And the third one is expected to be uranium bomb. This was done in 2013, but I think the focus of North Korea on uranium bomb started in 2008 when they demolished the cooling tower of Yongbyon reactor. And right after that, Kim Jong-il's, the father of the current leader, Kim Jong-un, health condition deteriorated significantly, and then they wanted to boost their nuclear materials capability. So we believe they started their, accelerated their enrichment activities, and that resulted in the third test, which was like 7 to 14 kiloton. And the fourth one is thought to be a boosted fission bomb, about 7 to 14. And then fifth one is a miniaturized, powerful bomb, 15 to 25 kiloton. So become really a threat for the countries like United States. They can mount this miniaturized bombs on the ICBM. And then the sixth one is thought to be a successful two-stage thermonuclear bomb with 200, maybe up to 350 kiloton. I think one of our colleagues from Korea is going to present the latest assessment of North Korea's nuclear weapon capability on that. So this information become critical in assessing North Korea's direction and evolution of their capability, and sort of verifies North Korea's claim that they have mastered the nuclear weapons capability. This information also becomes the basis, along with the other estimated nuclear weapons production capabilities and so on, for the estimation of North Korea's nuclear weapons arsenal, the possible path, and direct duration of the denuclearization effort, which is currently going on as part of the negotiation between North Korea, United States, and South Korea, and other parties. So this information provided by the monitoring stations and technical advice and so on become the critical pieces of information to move on in this very important time in the world. Thank you.
Great. Thank you very much. We'll now move to Li Peng, who's currently the Deputy Secretary General of the China Arms Control and Disarmament Association. He has spent his career working on arms control verification in various positions in the Chinese government and in the CTBTO, where he worked in the on-site inspections division from 2011 through 2013.
Thank you. Thank you for the invitation. I think it's a great pleasure after I left the on-site inspection division, CTBTO, 6 years ago. I think that arms control is closely connected with science and technology. And I think that actually, if you look at the arms control treaty, if you look at the treaty language, there will be political keywords like peace, security, signature, ratification, and you can also learn from the treaty that there is keywords like technical terms like seismic, infrasound, hydroacoustic, and also the multispectrum and so on. There was a presentation delivered by Mr. Ted Boyer. Actually, no matter it's a false positive or false negative, so there was one similar event in the history of arms control. If some of the experts may remember, that 20 years ago, there was a launch of a rocket, a sound rocket. Actually, this stimulated the misinterpretation of the early warning system, and actually it turned out to lead to one of the arms control procedures for de-alerting. We call it 4D during the arms control and disarmament process. And if we look back into the history of the CTBT, beginning from the threshold test ban and to the partial test ban or the comprehensive one. Actually, those procedures led directly to the development of the weapon technology itself, and also for the connected with the capability of verification capability. Sometimes the capability of verification is directly linked with the conclusion of a treaty. So this time, since my former Director General, Mr. He, is now also sitting there, he retired 10 years ago as former Secretary General, former Director General of Chinese Preparatory Secretariat on CTBT. And we, this time, come back to the CTBT as a team. And with the permission of my moderator, I want to add some color to this panel. I brought with me this new device. Actually, it was recently developed by our team. This is not a commercial promotion because we are thinking about to contribute this one to our on-site inspection division. This one is not a tablet. It is a 4-mode satellite navigation system. So I think this one will be a concrete example. I will illustrate a little bit more for this, because we have 4 globally coverage navigation system. That is the US GPS, the Russian GLONASS, and also the European Galileo, also Chinese Beidou. Those satellite navigation systems working harmonically together to contribute to the verification regime of the CTBT will lead to something. Because I think at the current stage, the universalization of this CTBT, the treaty itself, and it's very important, and even for the final entry to force of this regime. Thank you.
Thank you. And the last sort of intro remarks before we launch into the discussion from Mosa Mabusa, who is the Chief Executive Director for the Council for Geoscience in South Africa. He's spent his career in government and the private sector, where he's developed strategy, legislation, and technical assessments to ensure the link between science and good policy development in South Africa.
Thank you very much. Thank you for having us. The basis for science as a fulcrum for policy development, in our view, is unquestionable. In South Africa, I would share an example and experience with you. We have learned that ideological basis alone is not sufficient to inform and finalize development of policies. And there has been a marked shift in the recent past years to use a science-based policy development approach. I'll be the first to say that it is an early stage for us. And by way of an example, I wanted to share with the audience a slightly unrelated example to make the point. In 2010, the geoscience community uncovered 485 trillion cubic feet of shale gas deposit in South Africa. Now, we know the debates on shale gas. And when our government was confronted with a position of making a decision whether we will develop the shale gas or not, notwithstanding the excitement about the prospects of cost-effective energy security and independence, our government elected to delay the development of this resource, subject to a comprehensive geo-environmental baseline study being concluded. And there was a direct instruction on the scientists that the study must illuminate the risks of environmental degradation, and propose mitigation measures that will be imbued in policy instruments, so that in the event that the government decides to proceed with shale gas development, it would have been informed by the science. So I think we are moving in the right direction. Of course, the baseline was intended to inform those regulations also for monitoring and evaluation, as well as ensuring that we gain the public trust. And I emphasize the point about gaining the public trust because generally the scientists, the community and the public trusts the scientists more than they trust generally the policymakers. Having said, the South African position and the African continent in general, and I can speak with authority for emerging nations, is that we have not invested substantially in the capacity for scientific development, and that creates a disconnect and a glaring inconsistency in terms of the language that we're having. So in order for policymakers to trust the science must be trustworthy. And so if we have not invested sufficiently in the science, it then makes it a little bit difficult for the policymakers to entirely depend and trust what the science is telling them. And this paucity in the investment in science development generally is not only a challenge in the short term, but presents an opportunity for ourselves in the emerging nations and such treaties and establishment as the CTBT to streamline the capacity development in general. We are, after all, in the African continent, a youthful nation. We have the highest levels of unemployment and frustration, and such initiatives and the space that science presents could be largely part of the largest and greatest opportunity that we have in this space to redirect the policy direction and inform which direction policy must go. Thank you very much, Madam President.
Thank you. So we heard very different remarks, but also some similarities across them, sort of the needs for science to be effective and around communication and having the capacity to be able to do so. Heard a little bit about how technology and innovation can also be really important for getting information into the hands of policymakers, and how national efforts to develop technology can also feed into global goals, and about the importance really of trust in science. So to pick up on the last point, I might ask Mansang to talk a little bit about the capacity development piece of this, and in terms of sort of Korea's development over time and how that has shaped the responsibilities in terms of capacity development in the sciences for some of these issues.
Thank you, Marlon. National capacity building includes activities such as policymaking, regulation development, technology development, human capital development, funding, securing funding resources, coordination and management of national government, including intergovernmental activities, public involvement, international cooperation, and maybe more importantly, supporting national culture. So South Korea has gone through most of these activities. As many of you know, South Korea was one of the poorest countries in the world in 1950s and 60s. Right after the war, I think that national GDP was second to the lowest. But then as a donor-receiving country, they have developed, and now South Korea is the only country who have transitioned from a donor-receiving to aid donor country. So I think South Korea has the responsibility and maybe the willingness to share their experiences in developing the national capacity in various ways. For example, South Korea has now, I think, developed various training programs to support less developed countries. For example, Korea Institute of Nuclear Non-Proliferation and Control and Korea Institute of Nuclear Safety offers regular training courses in various areas: radiation monitoring, nuclear safety, nuclear security, non-proliferation, for the international community with focus on less developed countries. Korea Institute of Geoscience and Mineral Resources also conducts training courses in seismic monitoring for the international community. My center, NEREC, Nuclear Non-Proliferation Education Research Center within KAIST, offer summer training courses. Actually, it's called Summer Fellows Program, to raise future leaders in nuclear non-proliferation. Every summer, we bring in about 30 students from advanced nuclear power countries, nuclear newcomer or aspiring countries, and South Korea, because we believe humans are very important for the future of nuclear non-proliferation. And if these people, future leaders, can know each other, understand each other, appreciate each other, and work together in a very altruistic manner, we can solve the problems. So we bring in these students every summer, and then we teach, we make them work hard. They have to, Veronica sitting right there from Russia, she was on our fellow last year. We make sure that they grow professionally and they become successful. So far we have produced 124. This year we bring in 27 new students. And I think this effort is very important because we need people who understand technology, but we need people who also understand international issues and policy issues. And we need people to work together to solve global problems. So in a very small scale, we're doing that, and hopefully we'll be continuing that, and then some of the products will be in the future making difference.
Great. And Jonathan, maybe you can speak a little bit about OPCW's work. I think when we think about capacity building, as scientists, often we think about training the scientists, but I know there's work done in bridging the gap between the scientists and the diplomats, and so I don't know if you have your example of the book, but anything else you can speak about?
Sure. So one of the things that's quite interesting about this is that there are times when there are scientific evidence or scientific information that needs to be taken into a decision. And many times the diplomats will come with instructions from their capital, and they'll be asked to make certain statements or support a certain position. But there's also, the more you talk about science being important, the more there's a realization that you can't talk about science and say something that doesn't sound scientifically correct. So the diplomats have really been encouraging for the science advisor, myself, to actually do side events when they have their meetings to try to give them some of the technical aspects of information or advice that comes from the science board, for example. And on more contentious issues, the nerve agent report probably being the best example, we had briefings for them to try to talk about the technical aspects of decisions that were being put forward so that the delegations that didn't have access to science advisors from their capitals could follow the debates and follow the arguments that were being made. To facilitate that, Mellet mentioned the booklet. We basically took the list of chemicals of the Chemical Weapons Convention and added chemistry information, chemical structures, and explanations so that they could go and look at this and actually feel that they were understanding the basic pieces of it to have a better sense of and better confidence in when they were making the decisions and voting on decisions within the Executive Council. Is that?
So we're starting to get some questions in, so that's great. We'll be ready for that in just one moment. So, I think, Dr. Lee, to ask something that came up in our earlier conversation about sort of how to connect some of the technologies that you discussed to the verification regimes. Did you have any thoughts on that in general?
I think that the direct link between technology and the arms control regime is quite close. As I mentioned, that there was a directly link between the launch of the Sound rocket in North European region in the past, which actually led to the force alerting, and then there was almost a catastrophic reaction in that regard. So this actually directly led to the alerting and deactivation and so on, those for the arms control requirements. I think when I was involved into the conventional arms register for the United Nations, I remember in 2004, there was an accident probably involving the use of manpads by a group of actors towards the commercial airline. So there was scientific community suggestion that probably there will be a need to register the proliferation or export of the manpad system. Even though, as we all know, that 7 categories of conventional weapons would be registered to the United Nations, that will exclude the register of defense system, including air defense system. But from that instance, so with the suggestions from the scientific community, and this actually led to the extensive discussion in the United Nations about whether we should register this category of weapon, even though thinking about its nature of defense. So actually it turned out this category of weapon was registered into the UN register. If you look at the register's webpage, the manpad system will be registered annually to the United Nations. So I think there's absolutely a direct link between technology and arms control process. Thank you.
And Mosa, you've had quite a career in really sort of translating science into the hands of the people who need it. Do you have any thoughts on sort of best practices for scientists, things that have made you effective? Is it communication? Is it knowing the science? Is it being able to speak the language? What are some of the takeaways from your career in this space?
Well, I find that, and I can't speak with authority for the entire scientific community, but I find that within my community of science, our greatest difficulty is translating the scientific language into a language that policymakers can readily understand and appreciate and make informed choices based on our packaging of the scientific value proposition to the advancement of certain policy positions that are being considered, and so on. And I think it's a very important thing for us as scientists to learn where we haven't learned it. And I accept the point, for instance, with Jonathan, that if we have a chemical atlas equivalence and we make it available in the conference. But I think that still needs to be translated in a safe environment where policymakers understand what it means. And they are being explained to by people that they trust. That is very important. And this is why I'm making a point about emerging countries and lack of investment in the scientific and technology space in general, because who do they trust? They trust their own compatriots, and so they should. And so it is important, I think, that the ability of us as scientists to package and develop that value proposition in a way that the policymakers can understand readily will take us far quickly. Thank you.
Absolutely. I like the idea of value proposition and thinking about this particular idea. But one thing that struck me from listening to Jonathan's oral presentation earlier is really this whole idea that science advice needs to be properly packaged, but also that there are multiple other considerations in terms of the final decision that's made. And so, great example of a scientific advisory board putting together recommendations for a multinational or multilateral organization. But ultimately, the politicians and the national governments are the people who have to make the decision to do something with that information. So did you have any thoughts about how that tension, the scientific contention or consensus versus national goals and directions?
Yeah. I mean, it's very much the case that a technical piece of advice that looks at a scientific issue may not fit perfectly with some of the concerns about national level policies. It may not sit comfortably with some delegations. Not all delegations have access to science advisors. Some bring science advisors with them. Some refer back to their capital. So there's always the danger that when people are uncomfortable with the science, and the point about trust, I think, is really, really important, that if they're uncomfortable with the science, the answer will often be no, not because they're concerned about a policy implication, it's just that they're uncomfortable talking about the science and understanding it, so they don't want to have to deal with it. Better to leave things as they are. There is a formal and an informal part to the taking forward of science advice as well. Some states will have a reason, oftentimes it's coming from some of their national priorities, that they want to take forward some advice that comes from a science board, but at the international level, in terms of treaty policy, you can't get agreement. But there's nothing stopping them from implementing some of these recommendations in their own national capacity. And we actually see that quite often, where a state will sort of take a lead role, and they'll say, we think this is important, we've adopted it in our national capacity, and we urge others to do so as well. It still may be debated in the policymaking organs. It still may be that some countries are not quite trustful of the others as to why they're doing it, but at least you see things moving forward slowly.
Great. Well, we have some questions, but I just wanted to give the panelists, did anyone want to respond to anything that came up? Anything more you'd like to add before we change to question from the audience? Yeah.
So something about this science advisors' role in a multilateral perspectives and so on, but then also maybe in a global perspectives. So for example, when I was, when South Korea was preparing for the Nuclear Security Summit, 2011, the summit took place in 2002, which was started in 2010 by President Obama. The initial focus of the summit was to secure and remove fissile materials. But then now South Korea has an opportunity to host the second one in the series, and we as a group of advisors talked about what should be the focus or theme of the second summit. Of course, we should carry the focus that was raised by President Obama, but as a non-nuclear weapon state and as a country with heavy investment on nuclear power, I thought that we should think about radioactive materials, handling and the issue of potential dangers of radioactive materials coming from nuclear power plant, research labs, and hospitals, and etc. So we talked about the possibilities of securing those things, what we call securing those materials from the dangers of RDD, so-called dirty bomb. So the Security Summit included the agenda of the nuclear terrorism against misuse of radioactive materials, which become one of the topics of the Nuclear Security Summit in Seoul, which was carried by the third one in Hague. So I think experts with different perspective could add maybe the sort of focus of this global dialogue, which may have significant implications in the coming years. Also, in my personal capacity, I also worked for South Korean government when we're going through nuclear, what you call negotiations with the United States. Many of the nuclear power countries are supported by the United States, so they have to make what they call 1-2-3 agreement. Atomic Energy Act, Section 1-2-3 says all nuclear power cooperation with the United States has to come with some sort of agreement. So at that time, South Korea was going through these negotiations with the United States, and my role was basically to empower the ambassador to understand technical details so that he can actually understand what is involved and what would be desirable as an outcome. And in the end, I think the outcome was something both United States and South Korea could agree, but at a somewhat a different level. At least the South Korean government felt that it was a success, or United States government that it was still a success.
Great. I love how much expertise we have here and people who have really done these jobs. So as I mentioned, we had a broader discussion, and we'll move to the questions now. And there's two that I see that have come in from the audience already, and not surprisingly interested in thinking about applying this to CTBT. So we have a question for Li Peng in how can technical expertise contribute to CTBT ratification by China and the USA? Do you have thoughts on this question?
Oh, this sensitive question. I didn't expect that. But I will try to answer that within my personal capacity. But this will just express my personal opinion in this regard. I think that, as I said, with the example of this small device, the full mode navigation system, I think the issue of to promote the universalization is more awareness of this CTBT regime will be very critical. If I think it's in a correct way, if I'm correct, if you come to, let's say in China, if you go into the street, if you raise the issue of, do you know what is CTBT? When I was back in Beijing in 2012 for the 7th Satellite Navigation Conference, jointly held by Chinese government and also the UN WUSA, this UN Outer Space Office. So actually, I delivered a speech. It's not actually a presentation, a short presentation. What is the connection between satellite navigation system, the technology, and the CTBT verification regime? I saw those audiences sitting there with no emotion in their face. So I was kidding myself. When I raised the issue of CTBT, it's like talking about astronauts in the space is for you. So I think the point is that we make small step forward, probably through the joint effort together to make more awareness of this regime, and little by little we move slowly but steadily. I think we will reach some common consensus, and this will raise attention of these policymakers. This will promote the final target to come into true. That's my point. Thank you.
Good. And we have one more from the screen, and then we'll turn to the audience. So this is for Manzang. How could CTBTO contribute to the denuclearization of the Korean Peninsula through providing science-based expertise for monitoring the closure of the test site in the DPRK?
Tough question. I think this comes from Tariq. North Korea, we know, were willing at least to give up Yongbyon in exchange for whatever United States was ready to give. And I think President Trump thought it was not enough. So maybe the next thing could be offering CTBT, asking North Korea to join CTBT. I heard there is some initial dialogue between North Korea and CTBT. I think Executive Secretary has made some effort, and there is potentially some dialogue. So if President Trump thinks this could be another on the agenda, obviously they could discuss this as part of US DPRK summit. And also if that becomes part of the agreement, then I think the scientific capability through the implementation of IMS monitoring could become part of the confidence building measures. I think the key issue between the United States and North Korea is the trust or confidence building, because both parties do not see each other as someone who can trust. This long history of mistrust has been the real cause of the problem in solving North Korea nuclear weapons issue. So if this technological capability and monitoring data could be one of those confidence building measures, I think it could play a very significant role.
And I know there will be a session tomorrow as well, specifically on DPRK. So for those of you who are interested, and we do have one question from the audience. I'd like to get to that. And the microphone's coming to you. Yes.
Thank you very much, Soltani, a former ambassador to CTBT. The science, as a scientist, nuclear scientist, coming 37 years ago to diplomacy, I was shocked because I all my life learned 2 by 2 is 4. Diplomacy is 2 by 2 is 3 or 5 or negotiable. For the last 37 years, I found out that the only way is to bring these two people together. I was involved in OPCW too, and in any case, we brought scientists and diplomats together in the meetings, in the international meetings. And one of the good examples is Working Group B of CTBT. You have scientists and diplomats sitting together and working for the common cause. And this is the way. If scientists in isolation give for decision makers just some ideas, when those decision makers really do not digest and don't see all the aspects of it, they will make miscalculation and disaster. Therefore, the only way is to bring these two people, interact with each other within their country or in the international arena to work together so that we will have, of course, ultimate goal of better having the activities towards disarmament or arms control or non-proliferation. That's my idea and my experience. Thank you very much.
Absolutely. Thank you for that comment. And I think in general, that is absolutely the ideal way to solve those problems. I saw another hand over there. Yes.
Yes, I'd like to pick up on the trust science and advisors and policymakers. Now, we know science is industry-driven, and it's driven by large corporates. And those corporates, they do have arms in the policy making, in congresses, in royals or presidents. If you can comment or you have examples on how to proceed on such procedures when you do have the large corporates actually governing the policies and diplomacy. Thank you.
Okay. Well, I don't fully agree that science is all driven by large corporations. There's certainly a disproportionate amount of funding that comes to science from large corporations. But there's also a lot of science that happens because people have interesting ideas. It may eventually end up in a corporation. But each country, each state, has its own regulatory framework, has its own policies and laws. And a company, just like a large country who is trying to exert influence on others, the country has to negotiate with the governments that it intends to operate within the borders of. And so it's not that the company dictates, it's that the company also has to be somewhat of a diplomat. And it's interesting because this is an example I can think of that gets people to really think about how the world has changed and how we think about it. And that's important, I think, for policymaking as well as for science. But there's a company that I like to show a map of when I give presentations about what's happening in science and technology to the diplomats. And it shows a map of the world with indicators of chemical production and chemical research facilities located in the boundaries of 80 different states parties of the Chemical Weapons Convention. It's one chemical company. And the reality is when I hear the diplomats say my chemical industry, it's often a multilateral chemical industry. And in some ways, it mimics governance in a multilateral environment, and it also mimics what we think of as traditional business. And so I think as the world changes, policymakers also look to other sectors to see how do they regulate things, how do they work. And I think as we bring scientists and diplomats together, you cannot leave out the connection with industrial corporations either. And we see industrial scientists involved in some of the work we do, but it's also important to keep those ties and understand what they're thinking. If that makes sense.
And Mosa, not to put you on the spot, but I don't know if you have an answer to that. You worked in the private sector for quite a while and still do engage.
What we have attempted to do back at home is to establish science councils and giving them clear mandates on what their research focus should be on a particular topic of interest. And the contradiction, of course, always lies with the what Jonathan termed disproportionate funding. So you establish these science councils that are generally starved with resources to execute their mandate. So yes, even in science, in emerging economies, 2 times 2 isn't always 4. Because you have to juggle with all these difficulties, even in a scientific environment, where you are dealing with the contradictions of a science-based or research that seeks to inform policies, which you would generally wish for it to be ring-fenced, but you can't ring-fence it because you don't have resources, so you have to collaborate. And in the process of collaborating, how do you manage that in a way that the political advisors will continue to trust what you inform them and do not feel in any way that the collaboration is a subject of compromising the quality of the advice that you advance. So these are the constant difficulties that we are managing. We don't believe they are insurmountable. We believe that as a nation and as a global community of scientists, the best thing that we can do is to find such platforms as this one, streamline the collaborations in the international platforms, strengthen the argument of science. It will work to the benefit of advancing greater humanity at large. Thank you.
And the only thing I will add as well is I think, the science diplomacy conversations are often easy to say, scientists and diplomats, but to Jonathan's point, it's a whole ecosystem of people who are involved in this, from nonprofit organizations to the industry. Everyone has their own interests and sort of their own motivations, but also their own ability to help to get to the solutions I think that we're all trying to get to. So that's the only thing I would add. I saw a question in the back. Yes.
Thank you. I'm Ilya Kursenko from the CTBTO youth group. My previous thesis was on the history of the crucial steps in the sphere of arms control, particularly the second half of the 20th century. And I highlighted the 3 pillars that are crucial to making serious progress in arms control. The first is the role of political leaders. The second is the role of the expert and technical community that serves as advisors to the defense policies. And the third is the role of civil community that we've seen extremely crucial and active during the 1960s. And I am confident that the scientific community that serves as advisors is always in favor of actions towards arms control. The civil society seems to also be ready to mobilize to take more serious steps towards making efforts towards another arms control progress of this century. The political leaders are the ones that we can't predict about, and in my research I have never found a question on that, and I doubt I will. So I would like to ask the panel, how do you think what would motivate the current political leaders as they work on arms control?
And whoever wants to answer that is welcome to. Just note we have 4 minutes left in this session.
Well, I'll be very, very quick on this. I think the word trust comes to mind. As long as states don't trust each other, they're going to be hesitant to make agreements that they think may put them at a disadvantage.
I think that there was previous speaker, his remark actually I will share with the gentleman the same opinion. If you look at the Working Group B, all those delegations from different countries, the combination of their delegation, the team, will be different people from different directions. So that will involve politicians, scientists, military officers. So I think the involvement, the deeply involvement of those people, those actors, will play a role for the final decision making, even to the top level. Thank you.
I think politics reflects the public sentiments, what public wants. If the scientists and experts can work with the public in their communication efforts and convince the public to move into the right direction, eventually the politics, I think, follow.
Great, thank you. I have been told that I must end this session on time. So I want to thank the panelists for their diverse and expert opinions on this wide-ranging topic. And I know that there will be many more discussions this week that will touch on this, but thank you for allowing us to have this conversation. And let's thank our panelists.
indices. Correct?
But I wouldn't necessarily have them.
Difference.
Aïe, 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 aïe. Quelle mise. Faut que je pense à couper mon...
Many thanks.
Quelle misère.
Excellencies, ladies and gentlemen, dear friends of the CTBTO, thank you very much for joining us during an intense and I must say very impressive conference hosted by the organization. Our event tonight consists of two parts. A reception, which I'm told was already started and then stopped again, but there will be a reception just after this discussion. And before that, we will have actually a discussion with our distinguished panelists. We're very grateful for their presence. As the EU Deputy Permanent Representative, I am very pleased by this great turnout. And I will just introduce an important message from Brussels, then say a few words about our 40 years initiative, and introduce our speakers. So on the first point, I'm sure many of you have seen yesterday a message by High Representative Federica Mogherini screened in this very room about the close cooperation between the CTBTO and the EU. But we are lucky, we have another message by our High Representative that we would like to share with you. So please have a look.
Dear friends, 40 years ago, Vienna became one of the global capitals of multilateralism and international cooperation. And from the very first moment, the European Union was there to work side by side with the UN, with its agencies, and with the Organization for Security and Cooperation in Europe. Already back then, it was very clear that wherever multilateral cooperation is being used, that is also the European Union's place. And this is even more true today. Our world gets more complex by the day, and more it needs multilateral win-win solutions. Yet, too many are questioning multilateralism and the very idea of rules-based global governance. In these years, the European Union has become a global point of reference for all those who want to preserve, reform, and expand multilateralism. Our cooperation with all UN agencies is now closer than ever, including with those agencies based in Vienna, with offices in Vienna. The International Atomic Energy Agency is our constant interlocutor and partner and the benchmark in the work to implement and preserve the nuclear deal with Iran. We engage on a daily basis with the UNHCR and the IOM, for instance, to empty detention centers in Libya or to address refugee crises all around the world. The UN Industrial Development Organization and the Office on Drugs and Crime are essential partners in our work on sustainable development. For us Europeans, engaging with the UN system is the most natural choice because multilateralism is our DNA. But it is also the most effective choice as a guarantee of more democratic decisions that can better stand the test of time. These celebrations are not all about the past. Our support to the UN couldn't be more urgent for our present and for our future. I want to thank you all for being there, and happy anniversary to all of us.
So having heard the words of our High Representative, I wanted to add that on the 9th of May this year, Europe Day, we launched a series under the title EU-UN 40 Years Together in Vienna. You see the logo over there. Reflecting that in 1979, both the Vienna International Center, or VIC, and the EU delegation here in Vienna were established. A key aim of the initiative being to sensitize new audiences, the general public, students, think tanks, the media, but of course, very importantly also scientists, about how the EU and the organizations based in the VIC seek multilateral answers for global challenges, pointing to concrete and tangible achievements. We are therefore holding events outside of the VIC as well, focusing on one organization per month, and June in that context is devoted to the EU CTBTO partnership. More information is available on our website, and please follow us under our hashtag EUUNVIE on Twitter. Co-ownership and burden sharing with our EU member states, but also with third countries, is very important for us. So please feel free to share your views on our campaign, and feel free to approach us also with proposals, ideas for future events. Now it's time to zoom back in on the CTBTO. This crucial organization is, of course, still a bit younger than 40, but before that changes, we will hopefully be able to celebrate entry into force of the treaty. Our speakers have kindly agreed to share remarks with you, and in the interest of time, I will not summarize their impressive resumes. I'm delighted to give the floor first to the head of the EU delegation to the international organizations in Vienna, His Excellency Ambassador Didier Lenoir.
Thank you very much. And I would start by apologizing, Dr. Zerbo, for piggybacking on your wonderful conference to organize our event. But I think that these 40 years and celebrating our presence here in Vienna, celebrating multilateralism, this perfectly fit with the CTBT. I'm just saying that we like CTBT for what it does, but we also like CTBT for what it is. A very good example of effective multilateralism, pragmatism that was needed to overcome the challenge raised by the non-entry into force of the treaty. So again, I'm piggybacking on your reception, but it's to pay tribute to what you are doing and to what the organization is. I'd like also to thank the speaker for joining us. It demonstrates that we are not the only ones celebrating the CTBT. It testifies that multilateralism is, I would say, a value that is shared by many. On the CTBT, the fact that the EU is a staunch supporter of CTBT is well known. We are supporting CTBT politically. All our member states have signed, are ratified, and are supporting CTBT. I think we are probably one of the few, if not the only, regional group where all countries have actually signed and ratified the treaty, the CTBT. The High Representative, Madame Mogherini, is personally committed, personally engaged. She is a member of the group of eminent persons supporting the CTBT. She addressed the conference yesterday through a video message stating our conviction that the scientific and technological activities undertaken by the organization, and more broadly the cooperation with the scientific community, are essential to achieve CTBT universalization, to enhance the CTBTO verification regime, as well as to enable CTBT member states to reap the full benefits of the civil and scientific application of monitoring data. This Science and Technology Conference provides the treaty and its organization with a very welcome publicity and visibility. And we do welcome the contribution of the scientific community, and we want to pay tribute to the contribution of the scientific community to the work we all started more than 20 years ago. This contribution has been going on over the last 20 years along three main lines of activities. The entry into force, it might be perceived as a political process, but actually the scientific community can positively influence political decision makers in countries that still have to ratify the treaty and campaign for entry into force. The second line of activities, obviously, the operational activities of the organization and the detection of nuclear tests. The development of the international monitoring system and the international data center are major scientific and technological achievements, and the Executive Secretary is probably better placed than I am to explain why. It's a major contribution to our non-proliferation effort. So it's important to complete this effort, it's important to maintain the IMS, it's important to develop it. And we as EU, we would like to urge all state signatories that still have to establish monitoring stations to cooperate with the PTS in this regard. Third line of activities, the civil and scientific applications such as disaster management or atmospheric research. These are also very important elements delivered by the scientific community to the benefit of the international community. For all these reasons, the EU has been supporting the CTBT, not only politically, but also financially. I think since 2006, we have committed more than 23 million euros to CTBT. We have, I think, been distributing a number of brochures to explain where that money has gone. I would like to highlight two aspects of our cooperation. This cooperation is very operational, it's very concrete, and it benefits us all. Two examples maybe, the technical assistance and integrated capacity building. We have developed a program to assist third countries to establish and increase expertise in their national data centers. Experts from all continents have been benefiting from this workshop, from this training, from these capacity building activities, and now in a better place to use CTBT monitoring data, including for disaster warning or for research purposes. A second example is the enhancement of the CTBTO atmospheric transport modeling capabilities. The EU has been contributing to these activities to track the movement of airborne radioactive material. As a result, I mean, we have been able to, the organization, the PTS has been able to enhance high-resolution modeling and simulations, and these enhanced systems are now available. To sum up, I would say that these achievements so far mean that the CTBTO has provided the world with a truly global high-tech monitoring system for monitoring nuclear explosion with multiple benefits for development. This is something that no single country would have been able to develop alone. I'll stop there, but if you allow me a last word, I mean, we have a competition to identify a young scientist that has developed project matching EU priorities. There will be on Friday a Star Award that will be handed over to this scientist. So I call on all of you to cast your votes via the conference application. And once again, Executive Secretary, many thanks for everything you have been doing and your organization has been doing over the past years.
Thank you.
Thank you very much, Didier. Now let's hear the voice of the CTBTO, His Excellency Dr. Lassina Zerbo, the Executive Secretary.
Thank you, and thank you, Didier, for your kind words. It's always a pleasure to be at an event that EU is organizing, because you mentioned clearly that EU is one of the great supporters of the CTBT, both technically and politically. For a simple reason, EU represents collectively 40% of the budget of the organization, and you say that all EU members have signed and ratified the Comprehensive Test Ban Treaty. But I want to point out Ms. Mogherini's unwavering support to the Comprehensive Nuclear Test Ban Treaty. She is and she was a GEM member already before taking office as High Representative of the European Union for Foreign Affairs. And she decided to keep GEM membership within that function. As she told me, this was easy for her because all countries of EU are signatories and ratifying state of the Comprehensive Test Ban Treaty. And I think we can't thank her enough for what she has done. You've heard her video messages both yesterday and today. I haven't had a single hiccup with Ms. Mogherini when it was about getting or seeking her support for the CTBT and then for the work we do. And I think today it's a tribute to her and then to all of you for the leadership she has given to the EU engagement for the Comprehensive Nuclear Test Ban Treaty and her personal support to this treaty, and then to the overall framework of disarmament and non-proliferation. And I want to thank her here for that. As I thank you all, EU ambassadors in Vienna, I think you've been our strong supporters. We've had regular meetings where we could discuss issues at stake. We've done it in a transparent, objective manner, and then to see how best we can meet your expectation. And then I want to thank you for that too. Didier has gone through the level of contribution that you're giving to this organization, both to its verification regime in the build-up, and then political as well in terms of reaching out to people outside the EU context to make sure that we get the treaty as universal as possible. And you've done it with, I think, great success. We worked together to bring back the ratification of Angola. I think that was one of the EU first work together with the CTBT in terms of ratification. We're doing a lot together to get more and more ratification, and I'm sure we'll succeed. Even if sometimes people say I was talking to few now, and then I was at an EU event in Brussels a few years ago when somebody said, he said, but Mr. Zerbo, the CTBT is like a zombie because the treaty is not in force yet. I say, because I always see the glass half full. The good thing about a zombie is that it never dies. So whatever you do, and that's basically what the CTBT is about. It will never die. It's here to stay. If it's a zombie, make sure you run away because the zombie will still be there. And that's the beauty about this treaty. And then I want to thank the EU for giving us this strength and giving the strength to the zombie to stay up. And then even if some people push it back, and I can tell you the zombie will succeed and this treaty will enter into force. And the zombie will succeed also thanks to the involvement of youth. That has been one of our priorities. And you've seen the SnT featuring young scientists and policymakers all around, many women, young women involved, and then they're all in this room. And then, I mean, not all, but you will see them, doing a lot for this organization. And that's something that I'm certainly proud of. I think we started very small, and then now we have young people across the globe. And, I just saw Carlos. Carlos is probably one of the smiley face that you see all over the world when it's non-proliferation and when CTBT issues matter. And then I was asking Carlos, how's your mother in Texas? Because I did meet Carlos' mother, and then she was thanking me for having somebody like Carlos doing the job we do. And I think Carlos is here. And Carlos, you will never be old to not be part of the CTBT youth group, like many of you. And I want to thank all of you for the work you do, the young women and men that are working for the CTBT. I can't talk about all of you. I say Carlos because if you walk in the corridor and you see a smile, know it's Carlos. And that's the reason why I was talking about Carlos, but all of you are doing such a great job for the CTBT. But you've asked us to get you some mentoring. And the mentoring is coming from the group of eminent persons that was set up 5 years ago for the CTBT and by the CTBT. They've met today and yesterday, and then those are experienced diplomats and high-level officials. Some have retired. And as they say, because of the CTBT, if I take, for instance, Ambassador Hoffman, who is here, and you see Hoffman has been in every single session, and although he's over 80, because of the CTBT, he stays young. And I think he will make sure, like Bob Kemmerett as well, who often tell me, Lassina, I will never retire until this treaty is in force. So Bob is probably 83 today. Wherever I go, I say, please allow Bob to retire and get this treaty into force. So I want to thank the EU for helping Bob to retire by getting this treaty into force. Thank you so much for being here. Thank you.
Thank you very much, Dr. Zerbo, for reconfirming that the CTBTO is alive and kicking, and I think anybody attending this conference would be in a position to confirm that. This is really a very important conference, and this shows all the efforts that you're putting behind the agenda. Now, a lot of EU member states are represented in the audience. I see a lot of ambassadors here. And two of them are part of this panel. I would like to hand over the floor to one of them, the permanent representative of Italy, Her Excellency Maria Assunta Acili. Ambassador, the floor is yours.
Thank you so much. Let me start by thanking the EU delegation, and in particular Ambassador Didier Lenoir, for inviting me to say a few words today, and to share my personal experience as a chair of the PrepCom last year. I'm really glad that we can celebrate today the long-lasting and successful cooperation that we've had with the EU and the CTBTO over the past 40 years. the EU is first and foremost a peace project. CTBTO is as well a peace project. And this is why the mutually reinforcing action that the two institutions have been doing together over the past years is a reality, is important. And it has to continue in the future. From the Italian viewpoint, I can say that we have been a staunch supporter of the Comprehensive Nuclear Test Ban Treaty, which we consider to be a major building block of the current multilateral disarmament and non-proliferation architecture. This commitment to disarmament, arms control, and non-proliferation is an essential component of our foreign policy, and that is why we are particularly proud of the strong cohesion that the European Union has shown over the years in support of CTBTO. As a PrepCom chair, I have seized every opportunity to reinforce the sense of ownership and involvement among signatory and ratifying states to further spread the awareness of the CTBT's political relevance and practical usefulness, and to advocate for a prompt signature and ratification of the treaty by those states that have not yet done so. We have also launched at the end of the year 2018 the initiative of a resolution in the United Nations General Assembly, which was focused on the cooperation between the UN system and the PrepCom to further a close collaboration between the UN and the PrepCom. And the resolution tabled was co-sponsored by more than 60 countries, which means that, and it was eventually adopted by the General Assembly on 26 November 2018. This shows that there is awareness, and that the awareness of the importance of this organization is solid. We still have to work to promote the universalization of the treaty and its entry into force. That's why there is great need for state signatures to keep up their outreach and awareness-raising efforts, both at the highest political and diplomatic levels and within the civil society through a bottom-up approach. Events such as the CTBT Science and Technology Conference provide exactly an ideal platform for a dialogue that brings together policymakers, technical experts, scientists, academia, industry representatives, and younger generations, and allow us to give a very concrete contribution in this regard. Indeed, much still needs to be done, and I trust it can be done. As we say, when there is a will, there is a way. Our shared commitment to the universalization of the CTBT in the face of the current threats to global peace and security is crucial. Each of us has a role to play in this regard. And that's why I invite you all to work together to turn the political momentum into action and eventually reality. Thank you.
Thank you very much, Ambassador, for outlining what needs to be done and what your country is doing for entry into force of the treaty. Our ambassador highlighted that the 28 member states of the European Union have signed and ratified the treaty, but the same goes for many of the countries, for actually all of the countries that usually align with EU statements. So if you look at the numbers, that brings them, that makes them pass the 40 mark, actually. And we are very grateful for their alignment and for their support as well. Now, let's move a bit away geographically from Vienna and from Europe, but staying on the same topic and on the same messages, I would assume. I would like to hand the floor to Her Excellency Morakot Srisvasti, the permanent representative of Thailand, sharing her views. Ambassador.
Thank you very much. Thank you very much, Excellency Ambassador Didier Lenoir, the head of EU delegation, Excellency Dr. Lassina Serbo, the Executive Secretary of CTBTO, Excellencies, distinguished guests. First of all, I wish to offer my sincere felicitations to the EU delegations on reaching this 40 years of cooperation with the UN family in Vienna. I thank the EU delegation for organizing this event and for inviting me to share some experiences on Thailand's cooperation with the CTBTO. As you all may be aware, Thailand is one of the most recent countries to ratify the treaty in 2018, after signing in 1997. Yes, indeed, it is a very long time, 21 years. We took a long time. But I must say that I am proud to be a part of Thailand's effort to ratify the treaty from the very beginning to its conclusion, when we deposited the instrument of ratification in New York last September. The CTBT, or the zombie, as mentioned by the Executive Secretary, therefore holds a special place in my heart. I was a desk officer in Bangkok preparing Thailand's signature to the treaty in 1996, before being posted here in Vienna, working on the Working Group A, Working Group B, with the Ambassador Hoffman as the Executive Secretary, covering CTBT and other issues in Vienna. And again, before our ratification, I had a hand in pushing forward our ratification process in my capacity as the Director General of the International Organizations Department. The delay in our ratification has not in any way hindered our continuous cooperation with the CTBTO. We have long been hosting two IMS stations, namely the PS-41, a seismic station, and the RN-65, a radionuclide monitoring station. We also participated and benefited from a number of projects under the Technical Cooperation Program, some of which are funded by the EU, such as the project regarding the improvement of the noble gas measurements in South Asia, conducted in Chiang Mai province, as well as the training course on access and analysis of IMS radionuclide data and IDC products. The additional data on noble gas background in different regions really helped enabling the CTBTO to improve its international monitoring system and the data network worldwide. The technical cooperation program and sharing of experiences are therefore a crucial part of PTS work. The SnT helps provide further opportunity for the scientific community to meet and share new researches and innovations, as well as strengthening networks which will be helpful for enhancing cooperation in the future. Excellencies, distinguished guests, I believe that the past 40 years of the EU engagement with the UN and other international organizations in Vienna has yielded many successful collaborations, benefiting not only the EU-UN cooperation, but has extended to third parties as well. There are many great stories to tell, like the fact that all 28 member states of the EU have already ratified the CTBT. In ASEAN region, the Association of Southeast Asian Nations, we are also glad that all 10 members of ASEAN have ratified the CTBT, and that we have long been a nuclear weapon-free region. We sincerely hope that soon the CTBT will enter into force and help ensure global peace and stability with the ultimate goal of a world free of nuclear weapons. Meanwhile, Thailand stands ready to cooperate with the PTS and partner countries or organizations, including the EU, to promote the early entry into force of the treaty. I thank you.
Thank you very much indeed for these words, Ambassador, for also outlining how closely your personal biography is intertwined with the history of the CTBTO, and also for pointing out that ASEAN is similar to the EU in the fact that all the member states have signed and ratified. Actually, it so happens that tomorrow the EU delegation will have a meeting with ASEAN to discuss a number of issues, and that will be one of them. Now let's move back to the beautiful Mediterranean. We're very pleased to have here Her Excellency Natasha Meli-Daudet, the permanent representative of Malta. Ambassador.
Thank you, and thank you, Executive Secretary and Ambassador Lenoir for inviting me to be here. I'm particularly pleased to be here because I come from a country that, since its independence, has adopted a very principled position on disarmament and non-proliferation, a position that goes hand in hand and in line with the values of the CTBTO and obviously of the European Union now, even though we did sign and ratify the treaties before we actually became members. Now, a lot has been said about what the EU is doing and what individual countries are doing within the EU to keep on championing the values of the CTBTO and the entry into force of the treaty. But of course, even before the treaty enters into force, it is not a zombie and it is not a theoretical aim. I come from a country which is in the Mediterranean. It's placed on a seismic area, and I can myself cite one of the benefits that the treaty, even before it comes into force, is giving out to individual countries and to regions and to different parts of the world. We have a national data center that is in place and that allows us to receive and analyze data. And I was very happy to have Dr. Zerbo visit Malta a little over a month ago, and we have started discussions to have a tsunami warning agreement. My country, the last time we have recorded a tsunami was in 1908, but one never knows when it comes back. And so these are one of the few practical examples that where the treaty and the CTBTO is working and is leaving a positive impact on the daily lives of the individuals in the end. So no, the CTBT treaty is not a zombie. It is leaving a positive impact, but of course we have to look into the future and make sure that the universalization does take place. Now, the way we see it, if we want to let's say, come out of the cynical situation that we are finding ourselves in and perhaps the bleak sort of outlook that we have. I really believe that events like this are extremely positive, and maybe the future lies in the hands of science diplomacy, because we really need, as diplomats and the politicians who we seem to be struggling at the moment, we really need to start listening more to the empirical data and to the scientists and to listen a bit to them. And I would add a bit more, and I know that Dr. Zerbo is a big champion of this cause as well, science and youth. I know that when I was organizing his visit to Malta, he said, but you really have to make me meet with the youth, with the university students. I want to discuss with them, because from them I learn. He didn't want to preach to them, he wanted to learn from them. And I think we should all follow this line because we have a lot to learn. The youngsters are, in fact, our future. We have to learn from them. And it is, in fact, also one of the areas where the EU is financing and is assisting a lot through the training sessions of the CTBT youth group. So I want to end on a positive note. We should all keep on working, of course, towards universalization of the treaty because it is extremely important. But we should also give maybe a bit more space to our youth and to science and listen a bit more. Thank you very much.
Thank you very much, Ambassador. And particularly also for mentioning the importance of reaching out to youth. This is something that came up quite prominently yesterday at the opening segment, and this is also an important element of our 40 years, which is why I'm very pleased to now introduce our final speaker from the CTBTO youth group, which is, I think, a beacon in the context of involving younger generations in this important issue. So our last speaker is Mr. Samuel Leux. We've already gone a bit over the scheduled time, but we're looking forward to your remarks. Thank you so much for being here, and the floor is yours.
Thank you very much for inviting me to represent the CTBTO youth group at this panel. I'm Samuel. I'm the regional coordinator for North America and Western Europe for the CTBTO youth group. The link between the European Union and the CTBT youth group is strong and continues to get stronger. Thanks to the support of the European Union and others, our group has grown significantly over the past 3 years. In 2016, we started with only 20 CYG members. Today, we have reached 700 members in 90 countries, and we are still growing. Thanks to the EU voluntary contribution, our members have hosted international workshops, capacity building trainings, outreach activities, and intergenerational dialogues. For example, in July 2018, we convened an informative meeting with Jacek Bilika, the EU Special Envoy for Disarmament and Nuclear Non-Proliferation. Together with my fellow Belgian CYG members, we introduced to Mr. Bilika the work of the CTBT, its mission, as well as the role of the CYG. In August 2019, we hosted a conference in Kazakhstan where we brought together GEM and CYG members in a discussion about CTBT role in regional peace and security. This summer, we will host a capacity building training for 10 CYG members on new tools for nuclear non-proliferation and disarmament at the Monterrey Institute for International Studies. Finally, we are working to redesign the online educational curricula that aspiring CYG members will have to complete before becoming a CTBTO youth group member. As Dr. Zerbo always says, youth are not the leaders of the future, but they are the leaders of today. Our generation will have to work hard to make sure that the CTBT will finally enter into force. CTBTO youth group members are committed to this mission, and we look forward with the EU, Dr. Zerbo, and other member states to achieve this important goal. Thank you very much.
Thank you very much for sharing these remarks and for the fantastic work that the youth group is doing. Before we move to the reception, I would just like to thank once again our panelists for their presence, for their active participation. I would also like to thank the CTBTO for partnering with us, making this event possible. I would like to thank all of you for your attendance and your interest. And I would like to thank the core team in the EU delegation who made this possible. I would like to mention Attila Juhas, Alain Maton, and Gladys Marabo. Thank you very much. And we'll move to the reception. Thank you so much.
Thank you.
weighted directed graph, where the D graph is strongly connected and the total inflow must
Can we? Okay. Ladies and gentlemen, welcome to the last of our panels this evening, which is entitled Getting the Non-Proliferation and Disarmament Architecture Back on Track. Thanks for tearing yourselves away from the reception. I see some more still coming in right now. Before we get down to the panel itself, I would like to introduce for a lead-in address somebody with whom most of you here will be very familiar, Lord Browne of Ladyton, or Des Browne, who, amongst other things, is a member of the group of eminent persons for the CTBT. He has a very storied career, including being Secretary of State for Defence of the United Kingdom, and, of course, Vice Chair of the Nuclear Threat Initiative. And we're all very much looking forward to hearing what Des has to say. Thanks.
So good evening. Let me just adjust this. So thank you very much, Cormac, for those kind words of introduction. Before I start, this probably might not happen, but I have developed uncontrollably an irritating cough today. It certainly irritates me. I hope it doesn't, if it comes, irritate you also. So it's always a pleasure for me to be in this beautiful city, in this amazing building. I waltzed here once, many years ago. I don't think I could do it again, but I did. And I'm especially pleased to be here for this conference, which has grown exponentially into a very significant event, and deservedly so, because of the talent and achievement of the scientific and technical community who has built the Comprehensive Test Ban Treaty Organization's infrastructure. It's another pleasure, an additional pleasure to be here, because I find myself in this environment among many friends and colleagues, many of whom I've been working with for years on issues which are very dear to me and which I am particularly committed. And although over the last 10 years or so, this has been an increasingly difficult environment to hold the views that I hold, I am always energized by the number of people that I meet who believe broadly the same things as I do and are putting their shoulders to the wheel of trying to move us on to a better tomorrow. So they help me to retain my optimism for a better world on the basis that we will not always live in this place. So I'm honoured to provide these remarks to open this panel of distinguished speakers on the important subject of getting the non-proliferation and disarmament architecture back on track. I know that you are probably amazed by our bravery and optimism that we can provide those answers to this difficult challenge, but we'll do our best, I'm sure, and I have on this panel with me some great experts on that. The organisers have posed a series of questions for this panel, which include the prospects for a successful NPT review conference in 2020, the impact of regional and bilateral dynamics on non-proliferation and disarmament, and how practical steps can help get us back on track. I will address some of these questions in my comments and look forward to discussing them further in what I think will probably be the best part of this panel for you and for everyone, which is when we get to the kind of question and answer session and people from the audience engage with us. As many of you know, for several years now, I've followed these issues very closely. I believe that the non-proliferation and disarmament architecture is currently under threat. I'm not alone in that. The risks of nuclear weapon use, proliferation and nuclear terrorism continue to increase while the international community has become more divided than ever on the role of nuclear deterrence, the vision of nuclear disarmament, which recedes away from us, and the commitment of states to it and the steps required to prevent nuclear weapons use. The new treaty on the prohibition of nuclear weapons, the ban treaty, is one direct result of these divisions and the mounting frustrations felt by many countries on the perceived lack of progress. The polarisation among states increasingly has been threatening the stability of the NPT regime and its role as a central and credible forum for dialogue and progress on non-proliferation, disarmament and peaceful uses of nuclear energy. The fast approaching 2020 NPT review conference is an important milestone, but it's an opportunity for us to sustain, reaffirm and demonstrate the vital contribution of the NPT to reducing global dangers and advancing the goal of a world free of nuclear weapons. It's also an opportunity to reaffirm, strengthen and defend the important norm that has been established by the CTBT and to celebrate the successes of this treaty, which is critical to disarmament. Many of you in this room have demonstrated to the world that it is indeed possible to build a robust and reliable global monitoring and verification surveillance system, and one that has life-saving applications that go beyond the original intent. Anyone who knows me knows I am the biggest fan that this organisation has, and I feel compelled in these circumstances to thank you for your good work. The world now has a de facto moratorium on testing and has had for some considerable time, breaches by one country notwithstanding, and all in support of a treaty with 184 signatories and now 168 ratifications, one of the most broadly supported arms control treaties. You have every reason to be proud, and I'm proud to be here and to be associated with this very fine organisation. Against this background, there is much work to be done, and I will use my time today to focus on the following 4 priorities. First, to end the decline of arms control. Second, to act collectively to address new threats. Third, to enhance transparency and dialogue among states. And fourth, to expand and diversify the non-proliferation and disarmament community. First, ending the decline of arms control. A key contributor to the current situation that we find ourselves in is the eroding trust and confidence between the West and Russia. We're now witnessing a disintegration of arms control. Leaders should recall that in the past, each time a new US-Soviet or US-Russian nuclear arms control agreement was signed, the parties immediately started negotiations for the next one, or may indeed have already started them. Today, 9 years after approval of the New START Treaty, there is no agreed process or agenda for next steps on nuclear disarmament and risk reduction between Russia and the United States, who between them still possess, and I remind you of this, 90% of the world's nuclear weapons. If the INF were now to collapse, as looks likely, if not inevitable, in mutual Moscow-Washington recrimination, and the US and Russia allow the current political tension to undermine the possibility of extending New START, which must be agreed before February 2021, and the negotiation of its successor, we will return to an unregulated nuclear arms competition, the like of which has not been seen since the early days of the Cold War. Such a collapse would occur in the context of the recent US nuclear posture review that seemingly expands the role of nuclear weapons in US national security policy, concerns about Russia's nuclear doctrine and the new weapons it is developing, as well as its hybrid warfare activity along the NATO-Russia fault line and worsening tensions between West and Russia. This goes without saying, but I feel I'm compelled to say it, this is a dangerous situation. There's an urgent and immediate need to restore dialogue with Russia and to rebuild US-NATO-Russia relations. Lines of communication should be kept open insofar as it is possible, regardless of the level of tension. Dialogue is not a reward to be earned, but a constant diplomatic necessity, and the more so in times of impending crisis. Because of the nuclear risks this situation poses, the US and Russian leaders should also make a new declaration reconfirming the common view that a nuclear war cannot be won and must never be fought. If the US and Russia were to lead, other nuclear armed states should join such a statement. Second, addressing new threats. The decline in traditional arms control is one pathway to a nuclear mistake. Also magnifying the risks of nuclear weapons is the emergence of cyber and other technology threats to strategic warning systems and to the whole infrastructure of nuclear command and control that depends significantly on cyber-threatened systems. At present, there remains no constraints on and little government dialogue about this plethora of non-nuclear technologies that challenge us to think beyond traditional arms control measures. These technologies can make nuclear capabilities vulnerable and significantly destabilize the nuclear deterrent equations. In addition to halting the deterioration of traditional arms control mechanisms, we must also undertake efforts to better understand the risk to stability and global security inherent in the emerging of this new technology. Civil society and private industry have important roles to play in expanding this dialogue and providing opportunities for governments, experts, practitioners and others to engage and collectively identify recommendations on how we best address such threats. Third, enhancing transparency and dialogue among states. In the current environment, the challenges we face can only be addressed collectively, which means it is essential that we enhance transparency and dialogue not just between the United States and Russia, but among all states. The P5 process among the 5 recognised nuclear weapon states under the NPT must be strengthened, and countries should seek to create more opportunities for interactive dialogue among all the nuclear armed states, including to facilitate better understanding about nuclear use policies. Greater transparency among the P5 can help clarify misperceptions, strengthen mutual understanding and improve predictability of nuclear policies, plans, programmes and postures. It's also critical to enable long-term disarmament. I feel particularly qualified to define this job for the P5 because its very existence was as a consequence of my speech when I became the Secretary of State for Defence. It took a long time to get it to me, but I have some DNA on this. I have to say, I thought I was creating an arms control process that would advance disarmament. I've been shocked to discover that I created something very different, which I describe often as a cartel. Under the chair of the Chinese government over the past year, however, the P5, having held the first full-scale P5 conference since 2016 in Beijing in January of 2019, in addition to several rounds of ambassador-level consultations, and at the recent 2019 NPT PrepCom, the P5 announced their agreement to make discussions of nuclear doctrine a regular feature of the P5 agenda and to hold a joint public event in 2020. So things may be improving. Looking ahead, it's critical that this momentum, such as it is, continues under the UK chair of the P5. Discussions should be expanded to include an ongoing dialogue on how to reduce the role of nuclear weapons in security policies. This could include developing a set of agreed principles that all nuclear armed states would implement, including minimum deterrence, no first use, and forced postures that reduce nuclear risks by allowing more decision time for leaders. Even if such a discussion does not yield near-term shifts in policies, such a discussion would be valuable to help build trust and understanding. The P5 should also take leadership in working with other countries on WMD security, including nuclear material security, to prevent the threat of catastrophic terrorism. Emphasis should be given to improving security of radiological materials to counter the growing danger of terrorist acts with the use of a dirty bomb. It's also important that the P5 find opportunities to engage with the non-nuclear weapon states, including by sharing the outcomes of P5 discussions. Increasing transparency between the P5 and the non-nuclear weapon states can help strengthen accountability and will go some way to build trust among the NPT members. Finally, it's critical for the health of the NPT regime and the non-proliferation and disarmament community that we embrace inclusivity and diversity as a key element of strengthening the regime. We tend to spend a lot of time discussing and debating these issues amongst ourselves. And over the years, this has significantly narrowed the vocabulary we use, the creativity of our discussions, and the effectiveness of our efforts. Continuing down this path is no longer effective, nor is it sustainable. We live in an increasingly complex world with rapid changes in science and technology and a constantly shifting security environment. Moreover, all around us, communities are waking up and challenging the fact that too few people continue to dominate too many important areas of our lives. We will therefore remain limited in our influence, our credibility and our effectiveness unless we expand the voices, the backgrounds and the experiences represented in our efforts and debate. I came to the Women in Science and Technology panel last night, and I heard Joanna Bartley give us a lesson in the difference between diversity and inclusivity. It's a lesson which I take to heart. So increasing this diversity means, of course, that we should all adopt a more inclusive approach, looking beyond our own small communities to embrace diverse stakeholders, especially those with different viewpoints and experiences, and create new strong partnerships and opportunities for collaboration so that we can maintain pace with developments and further non-proliferation and disarmament progress in this much more complicated world. As said earlier, the scientific community has a very important role to play in this. Science and technology is now a critical element of many, if not all, aspects of people's lives. And there are important questions about the unintended consequences of these developments, including how they pose a threat to nuclear weapons. Policymakers and civil servants do not have the knowledge or expertise to be able to address this issue alone. Instead, we must develop deeper relationships and create opportunities for constant interaction with one another. Scientists need to invite politicians and officials who work in the policy environment into their environment and vice versa. So we all become more comfortable and familiar with one another and begin to share a common and more accessible vocabulary and dialogue. We must ensure that all our efforts have broad geographical representation. At present, debates, including within the NPT community, are generally dominated by a small number of states that hold well-known and unfortunately very deeply entrenched perspectives. This results in a fundamental lack of diversity in debates, increasing polarization of view, and a lack of opportunities to search for areas of convergence and creative new solutions. And finally, it should go without saying that gender parity must become a norm in this community. There are many countries and NGOs working hard to ensure that gender parity becomes an integral part of the community and our workplaces. All of us in this room should be joining these efforts and working to sustain or enhance gender diversity in our leadership staff and all initiatives and events. And we will not change this unless we confront it. So we should not be embarrassed or apologise for confronting this issue. It has to be confronted. My experience in public policy over many years is that we do not change bad behaviour by expecting people to change. We compel them to do so, and we should compel people to change these attitudes. So thank you again for the tremendous work that you all do and have done. We should all be very proud of the accomplishments that have been made in this field. And just as we must push our governments to carry their work forward, we must push ourselves to continue to expand and grow our communities and seek collaborative efforts to find creative solutions to the challenges we face. I look forward to our discussions. Thank you.
Thank you very much, Lord Brown, for that inspiring statement, which covered a lot of important issues from multilateral architecture for nuclear arms control and disarmament, gender parity, inclusivity, and diversity, all of which are very important for our continuing work. So I've been asked to moderate this panel. For those of you who do not know me, I'm Tariq Rauf, formerly Head of Verification and Security Policy Coordination at the IAEA. So our panel is Getting the Non-Proliferation and Disarmament Architecture Back on Track. We have 4 very distinguished panelists. I will not take up any time in talking about this issue now. I will have a few hard questions to address to the panelists after they've spoken. So let me introduce the 4 panelists in the order that they will be presenting, which is the same Deputy Director General in the Department for Africa and the Middle East. And I'm very pleased that she is a fellow alumna from the London School of Economics. Ambassador Pedastro.
It's working now, no?
It's working. Well, it's a pleasure to be here tonight and taking part in this, I would say, challenging, interesting, and very timely seminar on what are issues that are preventing a successful 2020 review conference, and what role the CTBT can play in the resilience of the MPT, and practical steps such as an FMNCT to be taken to get the non-proliferation and the disarmament architecture back on track. So what I would like to say is that with the 2020 review conference of the Treaty on the Non-Proliferation of Nuclear Weapons, we are before a new opportunity to re-examine where the disarmament and non-proliferation architecture is heading. We have the opportunity to assess the degree of the fulfillment both of the treaty as a whole and the commitments that we undertook back in 1995, in 2000, and in 2010 RevComs, including the 2010 Action Plan, as well as to draw up new proposals looking forward to the future. Now, after the three preparatory committees that we have just seen in the review cycle, we cannot say that we have made any tangible advances towards 2020. And let me share with you what are the circumstances that surround what I am saying right now. The 2020 RevCom faces important headwinds because, first of all, a clear fragmentation among the 5 nuclear weapon states, the traditional differences that we have already seen for the past years between NWS and non-nuclear weapon states, the lack of real and tangible disposition from the 5 nuclear weapon states to fulfill their commitments and obligations on disarmament, and the voices calling for increased military expenditure, as well as the increased rhetoric on the threat of the use of force while nuclear weapons are being modernized. So these are the issues that are surrounding the upcoming RevConf, and we should be mindful of this because it's not an easy context. Mexico is worried as well about the references that have been made by nuclear weapon states to the concept of creating the conditions for nuclear disarmament, or their efforts to normalize nuclear weapons, and the impasse on disarmament in various multilateral fora, including Geneva. So this normalization and institutionalization of this view would represent a significant regression for nuclear non-proliferation and disarmament, and would also constitute an invalid reinterpretation of a legally binding instrument. So there are several instruments at the same time that can help us try to help put on track and try to move forward with the MPT. First of all, the CTBT. We are here and we have been watching and listening to different seminars and that have taken place here. And we have listened to very interesting ideas. The fact of putting together scientists and technology here together with diplomacy has been a very important thing, along with youth and with women as well. But coming back to the MPT, the CTBT is a very important instrument that helps the MPT. Remember that the CTBT emerged from within the MPT process, and in fact, we consider it a litmus test of the commitment of the international community to MPT-led non-proliferation and disarmament. Mexico, the MPT as well, created an excellent overall framework. We should remember that it opened the door for further specific treaties and regimes in order to strengthen the implementation and achieve its goals. So there we have here the CTBT, but also the FMCT, or the nuclear export regimes control, like the nuclear supply group, and even the ban treaty, are part of this supporting architecture. Mexico is an unwavering supporter of the Comprehensive Nuclear Test Ban Treaty. We recognize the importance of the CTBT verification regime, and we welcome the scientific and civil uses of the international monitoring system and the international data center as a whole. We also condemn the conduct of nuclear tests by any actor and under any circumstance. In that sense, it is an active promoter of the CTBT as part of the 13 practical measures and as well of its universalization. We will continue in this regard to keep on calling for the, to continue to engage and call upon the Annex 2 states, which signature is absolutely essential, and also at the same time for states not to conduct any nuclear test and to refrain from any act contrary to the objective and the purpose of the treaty. Mexico will be playing also, we will be vice president of Article 14, and which is scheduled in New York on the 25th of September. And we will try to conceive innovative approaches for the ratification and the entry into force of the CTBT. And at the same time, while the entry into force takes place, we should and must ensure that all states refrain from conducting nuclear tests and other nuclear explosions or any other relevant non-explosive test, including subcritical and supercomputer-based experiments. But what could be also practical steps that could also be taken to get the non-proliferation and disarmament architecture back on track? We firmly believe that we need to conclude a treaty banning the production of fissile material for use in nuclear weapons or nuclear explosive devices, considering it to be yet another contribution towards the goal of the complete elimination of nuclear weapons. A fissile material cut-off treaty should be seen as part of a comprehensive and integral part of a process of nuclear disarmament and non-proliferation. As the regulation of fissile material for nuclear weapons or other existing nuclear explosive devices, it could also envisage a verification mechanism and confidence-building measures. So we recognize the various initiatives that have been approved in the UN General Assembly, including the FMCT expert and high-level groups. However, it is regrettable to see that their deliberations and reports have not yet led to negotiations. And then finally, I would say that at the beginning of June, we commemorated the 75th anniversary of the D-Day, and next year we will be marking the 75th anniversary of the bombing of Hiroshima and Nagasaki. These commemorations should serve as a sobering reminder of the importance of upholding the institutions that have kept us safe from another conflict on the scale of World War II. We will uphold its support for all processes and instruments that complement or strengthen the nuclear non-proliferation and disarmament architecture. Mexico believes that we must maintain the NPT process on track because we are fully committed to multilateralism as the right path towards the construction of a more peaceful world, founded on international law and the peaceful resolution of controversies. Mexico trusts and supports multilateralism as the only way to achieve sustainable peace, which translates into security and development for all nations. And that's why as well that we should get also lessons from other conventions that have been quite successful, as the Convention on Chemical Weapons and the one on biological weapons. There we had the will. We were very conscious of the importance of having an instrument that could work out. And finally, Mexico, on the treaty on the prohibition of nuclear weapons, Due to the devastating power, the indiscriminate effect of innocent civilians, the humanitarian impact, and the harmful effects on health, development, and the very existence of humanity, nuclear weapons for my country cannot be considered as beneficial in the hands of some and pernicious in the hands of others. This double standard is an incentive for proliferation and is contrary to the letter and the spirit of the agreements that we have signed. So we recall for ethical responsibility. We defend the ban treaty because we think it really complements and mutually reinforces Article 6 of the Non-Proliferation Treaty, and we would call all countries, and we will continue to do so, for its ratification and entry into force. Thank you very much.
Thank you very much, Ambassador Buenros from ASU, for covering a number of important points in your presentation, especially reminding us about the 75th anniversary of the use of nuclear weapons, which hopefully would be the one and only such anniversary, and also reminding us about the agreed NPT outcomes from 1995, 2000, and 2010 that seem to be forgotten in some quarters, particularly in these new discussions on creating the environment for nuclear disarmament. And also I recall that Mexico has been a long-standing defender of the Comprehensive Test Ban Treaty. At the 1990 NPT Review Conference, I remember Ambassador Miguel Marin Bosch presented a proposal on the CTBT that was not acceptable to some states, that led to a collapse of that conference. And also finally on an FMCT, despite 5 nuclear security summits, all military nuclear material is completely outside any transparency or monitoring. 1,900 tons of fissile material, good for 130,000 nuclear weapons. So our next speaker will be Dr. Ignacio Cartagena Núñez from the Ministry of Foreign Affairs of the Kingdom of Spain. He's currently the Director General for Non-Proliferation. He was Assistant Director General for Sub-Saharan Africa, Executive Advisor for Relations with the Parliament and the Foreign Minister's Cabinet. He's also served as a Deputy Permanent Representative of Spain to the Conference on Disarmament, and his doctoral dissertation was on the FMCT and the paralysis of the CD.
Thank you very much. Thank you for the invitation. To tell the truth, I had the opportunity to present my ideas on the non-proliferation regime in a number of times very recently, which drives me to the idea that if anything is proliferating besides some weapons of mass destruction and some delivery systems, is precisely this kind of existential meetings in which we try to think about where we stand in the non-proliferation regime, what we can do in order to preserve and to save it. So thank you very much. I would like to focus on 2 different aspects. Where we are as far as the non-proliferation regime is concerned, and where we are going to, and possibly, if I have time, what we can do in order to preserve the regime. Well, in my view, the current situation of the non-proliferation regime is characterized by 4 elements. The first one is no news to any of you, is paralysis. I mean, the non-proliferation regime has been paralyzed for 23 years now. We should further define what is paralysis, because what has been really paralyzed is what is called the traditional non-proliferation fora, as the ones that were recognized by the final document of the Special Session on Disarmament in 1978, the Conference on Disarmament and the Disarmament Commission. The Conference on Disarmament has been paralyzed for 23 years, meaning that in this period, only in 2 occasions there was a time in which there was some kind of consensus. It was in 1998, there was a very short-lived working group on FMCT that in fact lasted 2 weeks. And in 2009, there was some sort of agreement around of a very short-lived program of work as well. So 2 times in 23 years is not particularly a big track record. So there is paralysis. The second element I would like to underline is fatigue over this paralysis. this fatigue is linked to some extent to some lack of credibility. One can perceive in the multilateral meetings that there is some sort of fatigue. This can be seen, for example, in the delays of the contributions to many non-proliferation multilateral fora, or in the decay in the number of reports that are saying to the multilateral bodies. So basically, there is fatigue. In my view, and this is a personal impression, the ban treaty, the nuclear weapons ban treaty, is to some extent a sort of byproduct of this fatigue. The third element I would like to underline is what was defined to me by an NGO representative as lack of appetite for consensus and lots of appetite for posturing. I mean, one doesn't have to be a very skilled diplomat or a very profound observer to realize that there is not much room for non-proliferation in these days, and we constantly, hear about modernization of stockpiles and so on and so forth. And the fourth element I would like to underline is a newcomer in this perspective, which is some sort of disengagement, widespread disengagement vis-à-vis the idea that the regime has to be preserved at any cost. I was posted in Geneva 10 years ago, and I remember that, there was a motto which was respected by all the delegates in the Conference on Disarmament, which was, let's not rock the boat. There were, of course, very intense debates, huge conflicts, not only in the room, but also outside the room. But there was this idea that the institutions have to be preserved at any cost, because they are the very essence of the non-proliferation regime. Now, there is some sort of sense that, we could invent something else, and therefore, it's not that we will be rocking the boat itself, but, some parts of it could be, could fade away, because probably we could create something else. Well, this perception, this critical perception about the non-proliferation regime, in my view, is a little bit unfair. I'm a firm defender of the non-proliferation regime as it stands now. If we take into account that in 1961, President Kennedy predicted that in 10 years' time there would be 40 countries having access to the nuclear weapon, and now we see that the number of countries that possess the nuclear weapon are not beyond 10, well, some credit should be given to the non-proliferation regime for that. But even in terms of disarmament, you know that the peak of the nuclear weapons was reached in 1986, in which 67,000 nuclear weapons were deployed or stored. And now, the number has sensibly decreased. It is 15,000. Again, some credit should be given to the non-proliferation regime for that. So in my view, we have to the responsibility to preserve the non-proliferation regime. And what can we do for that? Well, I would give three ideas. First one is, let's not try to reinvent the wheel. The wheel is already invented. It took us very long to invent it. We have many documents which could guide future progress in terms of non-proliferation. I would underline two. The final document of the 1995 REFCON, the one that permitted the extension in time of the non-proliferation treaty, and the action plan adopted by the NPT in 2010. In my view, those are perfectly valid frameworks that should be fulfilled. If I would underline a measure that would be a clear sign of commitment towards the non-proliferation regime, I would say the ratification of, the entry into force of the CTBT. This is why we steadily support the efforts of the executive director in order to promote the universalization. The ratification is important not only by those countries included in Annex II, but also by any other country, because it's a sign of commitment vis-à-vis non-proliferation. Second idea, let's let the experts speak. in my view, I don't see any major disarmament or non-proliferation agreement coming in the next years. Things can change very, very, very quickly in this world. We all know it. But as of today, I don't see major new agreements. But in this time, we can try to reach tangible agreements on matters that are of interest to all of us. For example, nuclear risk reduction, or transparency in the stockpile management, or possibilities for disarmament verification when it will come. So these are experts' fields, so to say, in which we could progress, in which we could find areas for agreement. And the third idea, let's not rock the boat. Because, you know, if we start dismantling even part of the boat called non-proliferation regime, this could lead to a sort of normative vacuum. And the normative vacuum, it's an ideal field for proliferation of weapons of mass destruction. So we should, even if we all might be a little bit tired with lack of progress in traditional fora, we should still try, we should still preserve what we have, because it is not clear that we can find something to replace it in the near future. Thank you very much.
Thank you very much, Dr. Ignacio Cartagena Nunes, for reminding us about not rocking the boat, which I think is a very important principle to go by. You also mentioned the paralysis and fatigue in the non-proliferation and disarmament forum, and also the move away from consensus. Also, we should not forget that there is now a lack of civility, unfortunately, in the discourse between weapon states and non-weapon states, and among some non-weapon states itself. And finally, I'm glad you mentioned the final document of 1995 and the 2010 action plan. But I was surprised you didn't mention 2000, because in the view of some, the 2010 action plan was a walk back from some of the elements from 2000. But anyway, our next speaker is Ambassador Rafael Grossi, President-designate of the 2020 NPT Review Conference. Since July 2013, he has been the ambassador of Argentina to Austria, and also the permanent representative to the CTBTO, IAEA, and other UN organizations in Vienna. I have known him as my former colleague when he was Assistant Director General for Policy and Chef de Cabinet in the IAEA Director General's office. Before that, he has also served at the Organization for the Prohibition of Chemical Weapons, and he holds a PhD in international relations. Ambassador Grossi, the floor is yours.
Well, thank you very much. Good evening, everybody. It's a great pleasure to be here with so many friends with you, Tariq, my friend and colleague, to, of course, give my perspective from what is clearly a different place from all the others, since, like you said, I will have the honor and I will have the challenge of trying to steer what we all hope could be a successful review conference of the Non-Proliferation Treaty in a few months. I think it's important to do this and to have this conversation within the context of the science and technology conferences, which, as Lord Brown was reminding us, have grown into a place for a very nice mix of technical, scientific discussion as appropriate for the CTBT, but also for policy discussion, for policy evaluation and prognosis, as at least we are trying to do here when we talk about how we can correlate the CTBT and the NPT and the regime as such, which is a wider structure. And of course, one is really tempted to look back into the history of this strange couple, the CTBT and the NPT, which goes quite back in history with a few dramatic moments. You were recalling now, evoking the 1990 review conference, still in Geneva those days, still in Geneva, when it was the CTBT, or the lack thereof, which made the whole effort collapse. Then there would be other things, other single things that would have this disruptive effect in the NPT process. But still, the CTBT and the norm to stop in a legally binding way and verifiable way was always at the center of the discussions there. 1995, of course, the review and extension. The review and extension had this element as one of the most important ones. Those who were still in Geneva those days had that push that allowed the negotiators to go back to the shores of Lake Léman and finish it in a few months, with all the difficulties we know and what happened thereafter. You were reminding just now, Tariq, of the 2000, the practical steps. One of the most critical, most important steps there was, of course, the early entry into force of our treaty, and the 2010 action plan also included this in the list. So it's like a permanent feature. It's always there in a different form altogether, and we have to recognize that, because in spite of the anomalous situation that we are facing with the CTBT, in spite of this limbo that the instrument is still condemned to be evolving into, the CTBT and the Secretariat, from which we do have a number of very distinguished members here, and whose work I would like to applaud and salute, is delivering already. What would it be? What would be the situation I try to imagine around the nuclear testing in the Korean Peninsula if all of this was happening against the background of an absence of an institution like the CTBTO and the IMS? People could argue that events associated with nuclear tests could be alleged phenomena, perhaps pieces of imagination or ill-intentioned intelligence to accuse a state of doing what it shouldn't be doing. But luckily, we do have an instrument we all respect. We do have an institution we all trust, and that is not an issue anymore because of this. Of course, we need, we shouldn't rest on this comfort, because there are other elements which are so important that we are missing because of the non-entry into force, like the on-site inspections and other things that we could be having and benefiting from. But still, it's so important that we continue thinking about this. All of this to say that the CTBT has not lost any of its centrality when it comes to discussing the NPT and reviewing the NPT. And we've seen that. I think Alicia was also reminding us about the cycle, and she was giving us her assessment of the PrepComs. We can say in a certain sense that we've completed the formal part of the review cycle, since we have finished the 3 PrepComs. And in all of them, we've seen this recurrent discussion and this recurrent concern about in general, of course, the tensions and the stress on the legal framework, be it multilateral or bilateral between the big powers. But I should say that in spite of the lack, perhaps, of certain concrete recommendations that could be taken by me as president and all my fellow delegates in a few months, the PrepComs have achieved what is expected in terms of providing us with a very clear snapshot, with a very clear description of where we are the lines of tension, and what we should be trying to concentrate our efforts in the next few months, and in particular at the time of the conference. The thinking and the concerns about disarmament, or what within the NPT or in the NPT jargon is called the first pillar, is of course the object of consideration. I think Ignacio was mentioning some of the areas which seem to appear with certain regularity, I would say, in today's discourse when talking about what could be possible in the current circumstances when we talk multilaterally about disarmament. And he mentioned a few, so I will not repeat them. But still, there is this idea. A few days ago, 16 foreign ministers met in Stockholm precisely to discuss how best, or how we could instill some vigor into the disarmament discussion. I was there with two hats, if you want, with an Argentine hat, which is my permanent hat, and with the other hat, the hat that I wear for all of us as president designate. And I was, I would say, happy to see that a group of course, any group is arbitrary in its conformation, and one can always feel that one or the other was missing. But this group included non-aligned countries, included neutral countries, included NATO countries, included umbrella states. So a bit of the whole spectrum of security persuasions and affiliations. And still, it was possible to agree on a document which talks about disarmament, multilateral disarmament, and how to push this idea forward. There are other processes which are subject to discussion. We were just hearing about them. There is a process on the creation of the environment for nuclear disarmament. A few weeks ago in New York, a journalist was asking whether I thought that was something worthy of praise or consideration, given the fact that is being proposed by a nuclear weapon state. And I said, how can one be against something that has the word disarmament in the title? So let's engage in that discussion. Let's be there and present the case of nuclear disarmament and judge the product by its results. All I can say is that the challenge for all of us at this point, when we are talking about this architecture, and I'm coming to the end, to this architecture, is to be reminded of the fact that the NPT is the centerpiece of this whole structure. The NPT has set a certain order which is a human artifact, and as such has, of course, drawbacks, limitations, but it does have ambition as well. So perhaps the work for all of us together in a few months will be not only to reinforce, remember, and value the stabilizing factors in the NPT. In the words of Ignacio, I would say the not rocking the boat factors, but the ambition of the NPT as well, the ambition that is in the NPT. And for this, we will all need to come together and make a very, very determined effort to try to review the treaty, recommit to it, which is not a conservative notion. Recommitting to it is also recommitting to its ambition. I would stop here.
Thank you very much, Ambassador Grossi, for reminding us about this inextricable link between the CTBT and the NPT. You correctly, again, reminded us about the failure in 1990, but then in 95, just 5 years later, the CTBT was one of the essential elements that led to agreement on the principles and objectives and thus to the indefinite extension. So just 4 weeks ago, more than 150 NPT states parties meeting in New York expressed their confidence in you as being the president of our conference next year, which will mark the 50th anniversary of the NPT in force and also the 25th anniversary of its indefinite extension. Generally, presidents of conferences need to be conjurers and magicians. And in 1995, Ambassador Dhanapala, when he gavelled in the indefinite extension, said that the NPT president needs to be a magician and pull a rabbit out of a hat, but there needs to be a rabbit in the hat, and he also, or the rabbit also wants to come out. So that will be your challenge, to have an outcome that would be acceptable to everyone so that we can declare success and continue with this most fundamental of arms control treaties. Our next speaker is Professor Ivan Timofeyev from Moscow. He is the Director of Programs at the Russian International Affairs Council. Since 2015, he has also been the Program Director of the Valdai Discussion Club. Previously, he was head of Analytical Monitoring Center and Associate Professor at the Moscow State Institute of International Relations, called MAGIMO. He's also been elected as a professor in the Russian Academy of Military Science. He has more than 70 publications, and he holds a PhD from MAGIMO. Professor Timofeyev, the floor is yours.
Thank you very much, Mr. Chairman. First, it's a pleasure and privilege for me to participate and to make a contribution to the conference. And my first point will be on where we are and where we go. We are in a negative dynamics. On the one hand, we are facing a severe degradation of arms controls regime. The INF treaty is almost dead. The future of START treaty is uncertain. There are signs that the treaty will survive another term. At least there is demand in the US Congress to prolong this, and there is an emerging debate, positive debate, on the prolongation of the treaty. However, the long-term perspectives are quite unclear. There is a debate, an emerging debate between Russia and the United States on the commitment to CTBT. We all know about this. But this is, the problem is not just in the degradation of arms control. This is also about the crisis of multilateral diplomacy. One of the illustrative examples is the crisis of JCPOA, which was one of the principal achievements of multilateralism, multilateral diplomacy, and one of the principal achievements to control nuclear arms. We now have huge problems with JCPOA. Another problem is, of course, the penetration of other and the impact of other toxic topics on arms control agenda. From the Russian perspective, this is, of course, the tensions between Russia and the West over Ukraine and over other disagreements. And the problem is that these disagreements are growing up, and this doesn't lead to the mechanisms to prevent a future crisis. So that's quite an alarming side. But at the same time, it's it's easy to be a pessimist, and we can continue for a long time with fixing the problems. So the question is what to do. I agree that there is no necessity to invent the wheels. And the two basic recommendations are very simple, and they're quite old. The first one is to preserve existing institutions. It's clear that institutions matter, that institutions are more than just a cumulative effect of bilateral relations, and that they can accommodate bilateral or even multilateral disagreements in one way or another. And an example which I mentioned on emerging US-Russia debate on the commitment to CTBT is quite illustrative when CTBTO plays a very constructive role to accommodate this conversation. The second recommendation is also quite old, to adopt these institutions to new realities, to changing realities. These realities are transforming in a very rapid way. We have a revolution in military affairs. We have new readings, new understandings, and a new nature of strategic stability, an emerging towering role of cyber factor, the psychological decline of the tolerance to the use of nuclear weapons, the perspectives of the use of smaller warheads. So again, lots of new factors and realities. But the problem is that there is a conflict between these two recommendations, because when we are trying to adopt institutions to new realities, there is a huge risk to lose these institutions. I remember US-Russia debate, quite a constructive at the beginning, on missile defense. And the idea was not just to get rid of missile defense treaty, but to invent something new which would substitute the lack of rules of the game and would allow us to adopt to new realities. So what? What do we have? We lost the old rules, and we don't have new ones. Same is about INF. Recent discussion between Russians and Americans, beyond all of these problems in interpretations of the emergence of new systems. But one of the points was that we have China as an emerging players. Let's adapt to this new reality and think about something new. So what? Do we have something new? No. We have INF, which is almost dead. So inevitably we'll have to deal in one way or another with this conflict, but what is clear for me is that there is no better alternative for multilateralism, for multilateral diplomacy. And a good sign is that, for me personally, is that there is a readiness that this is one of the priorities for Russian diplomacy. I do not represent an official point of view, but what I see in Moscow is the readiness for a constructive dialogue in multilateral format. And this is, of course, a good sign from the Russian perspective. Thanks.
Thank you, Professor Timofeyev. You pointed out that at the moment we do not have a dialogue between the two principal nuclear armed states. This is the point that Lord Brown also made in his statement. This is the first time in the history of US-Russian arms control that there are no discussions on a follow-on treaty, and we are losing the existing architecture that we already have. With regard to the CTBT, you mentioned to preserve existing institutions, which I think is a very important point. We recall that when President Clinton signed the CTBT on the 24th of September 1996, he said this was history's longest sought, hardest fought prize, and it would be a pity if these existing architecture of the CTBT, NPT, and other treaties, which were not easy to achieve and took long discussions and negotiations and compromises, if we are to lose them without replacing them with equivalent multilateral structures. So we are 2 minutes from 9 o'clock, so I would like some guidance from the CTBTO Secretariat if Mr. Cormac O'Reilly could inform us whether we should continue or we should wind up. I can't see you from here because of the blinding lights.
Time for questions.
Okay. So floor is yours. Yeah, so it's better now so we can see a question right at the back. Could you please identify yourself, and if you could pose a direct question to any one of the panelists, we'd be most grateful. Thank you.
Hello, my name is John Walker from the UK Foreign Office. I've got a question for Lord Brown. How would you see your vision for the International Partnership for Nuclear Disarmament Verification to getting things back on track? And if you were back here in 2 years' time at SnT 2021, what would you like to see IP&D have achieved? Thank you.
Thank you. So let's collect a couple, and then we will give the podium a chance. Some others? Over here, in the front row.
Sorry. Hi, I'm Shervin Taharan. I'm with the Arms Control Association. I had a quick question for either Ambassador Grossi or Ms. Maciel from Mexico, especially considering we're going into the NPT review conference. You touched on this a little bit, but I was wondering if we could get a little bit more specific into how we can build the bridge between the TPNW and the CTBT, knowing that that'll be something we'll be talking about at RevCon. So yeah, would love to hear more about that.
So we'll probably take two more. So one in the front row over here.
Thank you very much. Very simply, Ambassador Grossi, the 2020, the business is not as usual because those commitments of Article 6 have not fulfilled. The expectation of 90 expansion is not there, and there are a lot of challenges. Good luck to you. This is a problem. And there is, regarding the arms control that was raised here, we want to reiterate this fact. The arms control legitimated nuclear weapons, and that is the mistake for the last decades, and put disarmament in the archive. We have to rethink about it. We want nuclear disarmament, no more arms control without any international verification. We should not deceive the public by these kind of things and reduce the importance of disarmament. And Article 6 is a real challenge that we should work for the timeline, and I hope that this is the issue in your conference, that it will be raised once forever for the future of the NPT. Thank you.
Thank you. So could we have a question or two for Professor Timofeyev and Mr. Cartagena-Nunes? If not, Lord Brown, and we'll work our way down the panel.
Yeah, so, I mean, I don't need to trouble people very long with an answer to this. I mean, this partnership, which was as a result of proposals that were put to the Obama State Department by colleagues of mine in NTI, and there is people know this, there's a partnership agreement which has sustained the change of executive in the United States, and it continues. But without going into the detail of what they are discussing, and I don't think that is necessary. I mean, we understand the importance of verification. The point has been made very forcefully in a question. The purpose of this is to do what I do a lot of, is to try to build trust and confidence among diverse partners that don't have any longer that trust and confidence, and we're going nowhere anytime soon unless we restore sufficient trust and confidence for people to be able, to challenge these enormous, the scope of the threats that we face in this current world. The probability of these happening may be small, but the consequences of them are enormous, of the catastrophic threats we face. We're concentrating on one particular and very immediate one because we have a series of institutions here that are failing. We have a professionalized, detailed, sort of group of experts who are failing to deliver for us, and we have no leadership, proper leadership in this regard. But you know, we could be talking about any one of these catastrophic risks we face, either in the environmental, technological, biological, natural, you know, or even some of the unknowns here today, and they would occupy us and should all frighten us very much. So the heart of what we're trying to do is allowing people to talk about issues which are challenging, you know, in an environment in which their views are respected, to build trust and confidence in the hope that that will create the environment in which they can address and take that elsewhere. And actually, you know, even in relation to these weapon systems, in the depths of the Cold War, there were these dialogues going on by people who were involved in maintaining, looking after, developing these weapon systems, the scientists, the technical people, the diplomats, in order to prepare us for the day that we got the leadership that was willing to engage in these issues. And that's what we're lacking at the moment. You know, we're lacking leaders who are brave enough in this challenging world to start to deal with the compromise that requires for us to deal with all of these challenges. And we can entrench ourselves in our positions for as long as we like, but none of us, not even the most able country in the world, can deal with these issues on their own. We all need each other.
Well, thank you very much for your question. First of all, I think that the most important thing is the NPT. The NPT is the cornerstone of the disarmament and the non-proliferation regime. You know that it is structured around 3 pillars, and that it's the only multilateral treaty that imposes on parties the obligation of starting negotiations in good faith towards general and complete disarmament, and establish the category of nuclear weapon states. So this is the most important thing. The contribution of the Ban Treaty is mainly to remember or recalling the importance of being able to advance and make progress in the disarmament sphere, in particular because of the humanitarian devastation and the implications that it would have. But the Ban Treaty will not be an obstacle at all, and Mexico and its partners will not allow it to be perceived as something that it's really competing. So the breach in general sense, I would say that both the NPT and the Ban Treaty are looking for the same objective, which is general and complete disarmament and a world free of nuclear weapons. And we firmly believe that but we are firmly behind a successful RepConf, and we trust all the way the experience, the intelligence, and the preparation of Ambassador Grossi, and Mexico will be behind him, and we will be looking forward to have a very successful RepConf. Thank you.
Thank you very much. I think Alicia has summarized very, very well this issue of the perceived competition or contradiction between these two instruments, as you were mentioning. I'm frequently asked about this, and I think that there's nothing to gain, I guess, from getting into a discussion on the merits of the TP and W in the context of the NPT review. You do not get into the review of a treaty to start talking about another instrument in international law. So, but that could be seen as a bureaucratic answer. I think it's not. The idea is that we set our sights on the treaty, the articles, Article 6 in this case, as Ambassador Soltanier was reminding us, and that is what will unite those in the room who may at the same time be subscribers, signatories of another instrument, which goes implicitly in the same direction, although in a different way. I think it's very important to avoid, and I say the same things for those who are extremely critical of the TP and W. I don't think the NPT discussion is a place to deride or to consider ill-willed initiatives that go in the direction of the abolition of nuclear weapons. It's a respectable position. It's a position that is well known, that has a long tradition in humanitarian law and also in international law. But I will, as far as I can, as president designate and as president, once we're getting into that, try to separate the waters between these two things, because I think no one would benefit from this discussion.
Professor Timofeyev, do you have any last comments? Dr. Cartagena Nunes, any last comments? No? So we had a very rich discussion, and I'm glad that Ambassador Grossi portrayed himself as Moses, parting the waves between the TPNW and the NPT. I wish him all success. So in the salon of the CTBT, we have an elephant with three aspects that we didn't get a chance to discuss, but keep this in mind. One is the role of the CTBTO in the denuclearization of the Korean Peninsula and verification of destruction of test sites in North Korea. Second, on the 23rd of September 2016, Security Council adopted Resolution 2310 on the CTBT. Now, Article 25 of the UN Charter enjoins all member states to implement the decisions of the Security Council, and hasn't been done. Third, NSG. 28 members of the EU are all members of the NSG, and there are 20 others. But there is a great reluctance to make the CTBT a factor for non-NPT states seeking membership and for any other state seeking membership. And finally, we have two competing approaches now. One is creating the environment for nuclear disarmament, which has swept the table clean. We forget about NPT 95, 2000, 2010, so outgo calls for universalizing and entry into force of the CTBT. On the other side, as Ambassador Grossi pointed out, is the Stockholm approach of 11th of June, the stepping stones to nuclear disarmament, where the previous NPT outcomes are back on the table, as reminded to us by Ambassador Buenos-Romasio, as well as the CTBT. So those are the choices in front of us. So thank you. Please join me in thanking the panel, and thank you very much for staying up so late. Thank you very much.